Good morning, everyone. Assalamu alaikum. It is my pleasure to welcome you all to the 205th edition for the Zak World of Façades conference series. My name is Shawn Samuel, and I am part of the organizing team here at Zak. Before we begin today's schedule, I'd like to give you all a quick, brief introduction. We started the Zak World of Façades conference series back in 2012, and since then we have successfully hosted 205 editions across almost 42 countries worldwide. This year marks our 6th edition in Riyadh, and it is always great to come back and see the growing enthusiasm from the Façade community each year here. I would also like to highlight that each of our events are unique in its own way. The topics differ from region to region. In some, it's about sustainability. In some, it's about carbon that we speak of. In some, about cost, and so on. So no two events are alike, and each event reflects the priorities and challenges of its own respective regions. Well, as you know, today Riyadh marks the last event for the 2025 year calendar before we begin 2026. This is the lineup for the next year 2026 calendar. I'd just like to highlight a few of these events. We'll be back in Riyadh again in the month of December, and Dubai would be in April. We'll also be going back to Cairo, Egypt, as well as Istanbul. So these were a few events that I wanted to highlight, and the rest is as you see on the screen here. Well, before we proceed, I'd like to take a moment to thank all our partners for this event today. To begin with Beam, they are gypsum-based cladding solutions. Cello are rain screen facade systems. CN Terracotta are into terracotta tiles. Dow are structural silicones, adhesives, sealants, and membranes. Ductal are UHPC, which are ultra-high performance concrete solutions. Effisus are weatherproofing and facade sealing systems. Euromax are again into coil-coated aluminium. Exa Ceramics are into ceramic slabs. Fassada are hybrid steel curtain wall systems. Fujairah Rockwool are mineral wool insulation and pacifier protection. Globebond are into metal composite panels. Granitec are porcelain ceramic slabs for cladding. Guibao are structural silicones, adhesives, and sealants. Haingya are high precision aluminium extruded solutions. Instalux are into aluminium door, window, and curtain wall systems. Janssen again into steel door, window, and curtain wall systems. Kale are into ceramic tiles. Kinlong are architectural hardware and facade fittings. Kurare are the parent company for Trossifol and Sentry Glass into laminated glass interlayers. Laswit into decorative and cast glass. Leaders Fort into terracotta and fiber cement cladding solutions. MSA, fire safety and fall protection systems. Obicon are again high performance coated architectural glass. ALWAN, powder coating for facade finishes. Screenline by Pelini, known for shading solutions through glass. Sidak, again oversized curve, security and ballistic glass. Seele are complex facade engineering solutions. Siderise are again acoustic and pacifier protection. Silka Stone are into stone laminated panels. Veneto Group are various metal cladding solutions. Shanghai Tongzhong are unitized curtain wall panels. Vitro are high performance coated architectural glass. Wacker, silicones and facade materials. Walnoma are again into various cladding solutions in aluminium and sheet metal. And Shinbao Glass are jumbo curve security and ballistic glass. Well, all our partners have booths outside at the foyer area, which you all must have seen. I'd encourage each one of you all do visit their booths to have a hands-on experience about their products and also basic understanding about the portfolio and their offerings that's there. Also, I'd like to inform you all that this event is being recorded and a YouTube link will be shared later. So all the presentations, if you all wish to revisit, you all can do so. But just note that the presentations for which we have received the permission will only be broadcasted in the YouTube link on the later stage. So without any further ado, I'd like to call upon our event convener and host for the day, architect Faisal Alghamdi from Gensler. He will be guiding you through the sessions and discussions until the end of the day. Thank you, and wishing you all a wonderful and an insightful conference. Over to you. Thank you.
Hello, hello. Hi, everyone. Assalamu alaikum wa rahmatullahi wa barakatuh. I hope everyone is really excited for this amazing day. My name is Faisal Alghamdi. I'm an architect in Gensler. Looking always to be in this kind of amazing event. That's really, I call it something. I call these kind of events as the place or the heaven of sharing knowledge. Sharing knowledge, connect with people, network with different expertise and different disciplines. So all of that in one place. So I would encourage all of you to be really engaged, grab coffee or a cup of tea, and so let's begin. And we have a lot of speakers who are really amazing and experts in Façade and all of that thing. I will start with introducing our amazing architect Ahmad from Clear Architects.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. Thanks for being here today. I'm honored to speak in international conference with Zak in Riyadh for this year 2025. My name is Ahmad Fuad Marrwa. I'm an architect and have master's degree from King's University in modern construction technologies from King's University, and I have more 10 years experience in Saudi market with local and international companies in different engineering fields, and I am now in Clear Engineering Office as a project control director. These samples are brief about Clear projects. Already we are specialized in high-rise and medium-rise building. We are support our developer and our client with all engineering disciplines, even though in architectural, structural, electrical, mechanical, and all the specialized engineering fields all the time. And until now, we have more than 55 towers in Riyadh. Our presentation for today is early integration in facade design. So to introduce about our presentation, what is the meaning of the early integration? That's mean bringing the architect team, facade team, structural team, AB team, all of engineering disciplines in our project from day one. Also with all the facade elements like facade contractor or fabricator, aluminum supplier, cladding supplier, glass supplier, all of them from day one to working together from day one to ensure that all things is aligned with the construction and another facade systems with or by engineering methods to define the aluminum solution, glass solution, and glass specification or aluminum specification, our other cladding to solve and reduce any problems in facade system and facade solution or the integration between all the disciplines in our project, and to work within the budget and control the budget from the beginning. And our company have the vision, what we design, that exactly what we build in the site. Okay, what is the importance for early integration? Today, facade design is not optional. It's most critical element define the success or failure of any modern building in the world. The facade represent only 20 to 25% of construction cost overall, but it's controlled more than 40 to 60% of the energy and operational cost. So that's meaning the facade is not decoration, is decision. Is investment decision and is engineering decision all the time from day one. So in any facade project, we have four main players. They must work together from day one with the maestro of them. There is supplier, there are supplier, fabricator, designer, and developer. Now let's start in designer. Designer who leads the project from day one with all other stakeholders, and his work like maestro. He defines the rules for all other stakeholders. Okay, so each one have the responsibility, and if he work with the best time and the best solution and the best ways, he will to get the highest benefits all the time, and he can to let us control of our project in any time and any statement. So by ensuring internal coordination, we will get the zero clashes in our project, and it's one of most important things in any project. And if we managing the expertise and the specialist, we'll achieve the decision speed. And even though if we designing within the budget, we will build absolute the client trust all the time. There is another important point like performance. So if I ensuring the performance and the maintenance all the time, we will ensure to get the best product and superior product. Let's move to the second main player in our stakeholder. There is the developer. Developer, he's our client and he's our target audience, and all the time work together to achieve the success story with him. So there is more responsibilities and benefits. So by ensuring the vision and budget clarity, we will achieve the cost certainly. And if we invest the time from early, we will achieve overall the speed of delivery. The same things, if we adopting the facade and assist, we will maximize the project value or investment value. There is another point of we ensuring the supporting coordination, risk mitigation, and if we appointing the specialized team with our stakeholders in all the specialized, we will to secure and maximize his ROI, because we all the time need to protect the investment. The investor of the developer and the investment. Now the third stakeholder or the third main player, he's the facade contractor. Facade contractor, I'm trust and I'm sure the facade contractor who have that balance all the time, and if he make the fully integration with the other stakeholders, he will to achieve his project and he will to achieve his he will to achieve his project because he have the keys success with other stakeholders. So instead of just pricing, we can offer execution, the solution to achieve the de-risk in the site. And instead of the low price, we can offer by value engineering to protect his profit margin, and commit to secret documentation to build a sustainable partnership. So, and finally, by focusing on performance and quality, they become the partners, not only workers. And now to the fourth main player in our stakeholders, and the fourth main player in our stakeholder, there's the supplier. The supplier who need as partner, not as supply the materials without anything. So if the supplier provide the early technical support, we will secure, or he will secure his market share all the time. And when he deliver on the time, he will win the project and for the smooth production all the time. And provide the quality, and if he provide the quality and compliance, he will avoid the rejection and lose in his project. And finally, focusing on quality and performance and innovation, he will make and build the strong brand in the market. We presented the stakeholders, we presented the introduction and the responsibilities and the benefit for each one. But now, what is behind the facade? Because the facade is not only glass and not only aluminum or not only just visual and architectural and amazing architectural concept, he have more important numbers if we try to achieve this between the collaboration and coordination between all the engineering disciplines. So if we improving and introduce the SHGC, we will reduce the HVAC load. And if we using the low E coating, we will save the energy of our facade elements and our structural elements. And if we improve the U value, we will to reduce the heat loss. Regarding to another important point, like annual maintenance, like the value of investment, like the facade cost as part of total construction, there is another important point. So it's the most impactful part of the building in performance, cost, and operation. Now let's move from theories to the reality. In our company, we have the vision. What we design, that exactly what will to build in the site or in the market. So Arams is one of our client and his real estate development. And now we will to introduce how make the early integration with our partner and our success partner with our project. There is some of our stakeholders, our success partner in company. Already we have vendor list we issued to any developer from day one to select some of them on what he need to work from day one. But important point that it's not important who he work within in this stage, he will to win the project. So now we will to explain how we work aligned and in parallel with all stakeholders and all the supplier with our project. So already we integrated between the facade system and the structure and the construction of the building by load points, by movement and fixing bases to ensure that our project already with zero conflict between the facade systems and the structure system. Already in the same things between the integration between MEB and the facade system, all the time we trying to, from day one we ensuring the isolation to reduce the HVAC load, and we make the BMU access for cleaning and for maintenance from day one with our partner. In the same thing, the lighting is not added later on. The lighting already that built in the project from day one. So we hid the roots already. We fixing the details. We fixing the details with and make full coordination and full integration with other partners and other suppliers. So from day one, we make the full integration and full collaboration with all engineering disciplines and all facade supplier and all facade elements to ensure that our project that will execute in the site with the same what we designed before. There are some specifications, some specification and some detailed drawing, structure study that aluminum supplier issued from day one. We issued from the beginning, not from day one. We issued from the beginning in technical report based on his experience, based on his selection, and based on his product, and based on what the information that issued by the designer, like tunnel, wind tunnel and wind load, and other structure important information that issued by the designer to select the best solution for the aluminum and best practice and best specification. Now for the glass. In the same things, already we the glass supplier issue the technical report with all the specification and all the analysis like sunbath analysis, solar radiation, daylight analysis to achieve our goals regarding or based on our U value that the engineering office issue to glass suppliers to work within and to ensure that our design in architectural wise, in engineering wise, and in facade wise will align from the beginning and from day one, and all the time if there any modification we can to handle anytime. Okay. Now we presented the external cladding as porcelain. Already we select one of cladding material that aligned with Salman style. The materials there have a specification and some technical information. Already we sent to the fixation company to define the best solution and to define the best systems is suitable to our project regarding our construction system and regarding any important for any technical information regarding to our project and regarding the cost, because all the time try to work within the budget. So lighting is one of most important points, and the lighting designer, if he handle and if he specializes in these things, he can to handle this one, and he can to clarify your architectural concept with the best solution, with our stakeholder, with another stakeholders, and with the best fixation, he can to innovate the best solution to fix and apply the lighting lines with the full coordination and full integration with another engineering disciplines and another supplier in the facade. Now, what our recommendation? We have, as clear and are based on our experience, we have 4 points. Until now, we cover only the 4th point. So it's important to require a complete facade study before approving any drawing. Create national system to approve facade materials and systems. Link building permits, yes, again, link building permits to a facade performance certificate. And 4 things, promote early integration by involving supplier and contractor from day one, applying, designing, and assist. So clear, and our company and based our experience in this one, we didn't wait for more time. We created our own innovation and named Facade Committee. We will Facade Committee to combine many supplier materials in facade to issue the best solution with other one, and to issue the best catalog for the developer can to work with and like the guidelines. What is the conclusion? Saudi Arabia is building the future at a scale the world has never seen, and the facade is the face of the future in Riyadh and in Saudi Arabia overall. World-class cities demand on world-class facade, engineered with precision and coordinated across all disciplines and integrated from day one. Thanks for listening. Thanks for all. Thank you.
Great. Thank you, Mr. Ahmad. It was really amazing to show all of these and showing this case study for integration, early integration of facade design. And now please welcome on the stage Mr. David from Schlaich, Bergermann partner. Please.
Thank you. Hello everyone, my name is David Sommer. I'm the managing director of Schlaich, Bergermann and Partner from Germany, managing director of the newly set up office here in Riyadh, and it's a pleasure for me to be speaking to you today. Just from the beginning, I want to mention I'm more coming from a structural background, so I'm not a facade expert, but every facade we develop in SBP is strongly related to also an innovative structural system behind it. Okay, my speech today will be showing the diversity of architectural facades in the Middle East based on 3 case studies. The first case study will be a very solid stone facade. The second example will be a very lightweight membrane curtain, and the third project will be basically a facade that can disappear. So let's see how this will turn out. In SBP, so I give you a short introduction, we are currently around 300 people, a very colorful bunch of skilled experts in the engineering field. We are mostly coming from the structural background, but we also do civil engineering, facade engineering, bridge design, lighting design, basically on all types of projects, like maybe you know our stadium projects, cultural building, bridges, high-rise towers. Basically, whatever interesting idea you want to execute, we will engineer a very good and innovative solution for you. And of course, we also working in the fields of facades. We have currently around 9 offices worldwide, with the latest addition to this. Let's try the pointer. Anyways, Riyadh is the 9th office. We added to our world wide offices, and we got the commercial registration in the middle of this year. But we have been active in the region for many decades, starting in Riyadh with King Fahd Stadium in the 1980s. Then we have been working on a lot of stadiums in Qatar, in Abu Dhabi, in Dubai, and finally we are here in Riyadh. So here you see a overview of the different facades we have been doing. So you see it's not always the typical curtain wall facade. It's often related to cable net structures, structural glass, membranes, and all kinds of innovative solutions. The one on the upper left here is the first. Oh, now it's working. Is the first ever built pre-stressed cable net facade in the airport of München, for example. Okay, let's start with the first project. So the first project is the Royal Diriyah Opera House, which is currently under construction here in Riyadh. We have won this competition together with Noheta. You might have seen the winning rendering, which is, I think it's going to be an outstanding project for the city. And just to give you a bit of an architectural background, like you see, the Opera House will have the main auditorium here, 2,000 seater, which is this one. Then we have a multifunctional hall here. Also on top, there's another level for performance. And when you then go up here, the spiral staircase, you will reach this breathtaking outdoor amphitheater with a view over Diriyah. For this project, SBP has done the structural and the facade engineering. So I just give you a bit of a background. We start with a 2-level concrete basement. Then everything that was possible we designed in concrete. And then the complex elements of the opera house, the ones you see in blue, are a steel structure. So this is the base where we have to put the facade onto. And here you see how the facade is looking like. So we have this horizontal layering with openings and then big cutouts with glass. And I think the architects and the whole design team, we did a really great job in taking the layering of the rock of Riyadh, as we see it everywhere, and translating this onto a very modern opera house building. So here we see the key principles of Salmani architecture. As we are always reminded, we are here in Riyadh, we need to follow, or we should respect the Salmani ideas of designing. So what does it mean? We are designing we are reflecting cultural identity, we are integrating traditional architectural elements, we must design to prioritize people, we should be innovative, and I think this facade design is a very, let's say, modern and smart way of applying these ideas of Salmani architecture to a modern cultural building. All right. One step back. So the Opera House is the first icon in Diriyah Phase 2, which is already under construction. You see here a photo which is roughly 2 months old. The general contractor has been chosen, also the facade contractor has been chosen, and now I'm gonna jump into the real topic. How did we design this facade? So the main material is natural stone. It will be applied to the external walls, but also partially inside the building. We have chosen the yellow Riyadh stone, and here you see the different colorization or how it will turn out as the design of the building. The minimum thickness of the stone will be 50 millimeters. It's quite thick. This is due to very high bomb blast requirements that were in our basis of design. So after choosing the stone, we were trying to see how can we actually segment the different horizontal layering. So you see, like, the smallest singular stone is a 200 millimeter stone, which can be attached by 2 agrafs. And then when we go smaller, we actually need to split the stone by some dummy joints. Yeah. So these are the rules we have set up for the facade, and here you see how this is translated into the singular stones. So the smallest singular stone, the smallest singular hook stone, and then whenever we want to add additional horizontal layers, we're using such a dummy stone here to get the pattern we wanted to achieve. With this as a base, we took the base volume, we layered it horizontally from 50 millimeter to 500. Only in the 300, 400, 500 we added the windows to keep the detailing possible. And then in the third step, we took all this and added this combination rule that stones cannot be smaller than 200 millimeter. And then you see the end product on a singular element of the building. And this we applied to the entire facade. So you see each and every stone of this building is defined, right? Certain zones of the building we are using GFRC, mainly here in the soffit area due to a reduced weight, but also as it is an artificial stone, it just has a higher reliability of not falling down. So after choosing the material, we now need to see how do we add, with what kind of facade systems are we adding the stone to the building. So you see, in certain zones we have the concrete behind, in other zones we have the steel behind, so we are having a standing seam and a stick system. Then we have the overhanging GFRC and the large glass openings in the building. I'm just running you through some details. So you see this is the typical detail of the rear ventilated facade on the concrete. Also with the window integrated here running along the insulation line. Then in the zones where we have a steel primary structure, And little window openings, we're using a standing seam system. In zones where we have many windows, we change the standing seam to a stick system. You can see this here. So here is the primary structure of the building marked in red. The windows here, they are not really windows, they are just niches. And then we run the stick system around the real window openings to give the architects the maximum flexibility in generating the outer aesthetic of this building. Then, of course, we have these overhanging elements with the GFRC cladding. The detailing is a bit easier because in most cases this part of the building is not insulated. And now, coming to an end, we also see here the very big 16-meter tall glass panels supported by by glass fins. Also, this system had very high explosion loads. So what we did, how do we solve it? We said, okay, first of all, the glass is standing on the bottom, right? It's under compression. And then in a big bomb event, which will hopefully never happen, the fin might break, but then we have this metal element here, which will be activated as a tension element via the slotted hole. So when the fin breaks and it's overhanging, the steel element will still make sure that this facade is resting in place and is not falling over. And also this we all engineered in-house, and yeah, it will be breathtaking to see this very solid building, and then you have these almost Apple Store-like opening entrances to the building. This is a mock-up in front of the Riyadh client's office. It's not an official architectural mock-up. It was done by a stone supplier just to showcase, and there will be a lot of changes, but I think we can see already that it's going to be a really breathtaking building at the end. And we're also working on some ideas of Riyadh Stone 2.0. So we see a lot of the opaque buildings here. Some of our architectural clients, they are interested in seeing a stone building during the day, but then you can backlit the facade here, and as the stone is not really a real natural stone, but it's a veneer on a glass, this building might start to turn and glow in the night. So I think it could be a very interesting way of bringing a bit of variety to the architectural facades of the city. Okay. So after the very solid facade, I'm continuing with Al Tumama Stadium in Qatar. This was a stadium we designed for the World Cup in Qatar. And Al Tumama Stadium is something very different than Opera House in Riyadh. So here we see the architectural design the idea comes from the gaffia, the traditional woven head cover of the Gulf region. And the architect took the pattern and this whole idea of weaving into the architectural design of this stadium. And we engineered a really beautiful, perfect circular ring girder roof of it. You see like how the bracings are picking up the idea of this weaving. Then on top of the structure, we parametrized the openings so that the translucency of these elements are more oriented towards the south with how the sun is going, so that you have most of the sun rays hitting into the stadium to activate the grass growth on the pitch. Then the vertical facade is picking up the 40 grid axis of the building, and we have a 40-meter tall, around 18-meter wide base. And we are not just using a typical aluminum substructure and aluminum cladding, as it is done in 95% of the solutions, I would say. But we made a super lightweight cable net structure that is following the overall shape. You see it here. So first of all, the vertical girders, 40 meter high, 18 meter spacing. Then we integrated this upper and lower truss, which is able to take the tension forces of the cable net. The cable net is following the big overall shape of the building and is also in a fish beam shape, so it's picking up the bending moment of the resistant element, and then we just throw a PTFE membrane over it, stress it from bottom to top, and pin it at points towards the cable net. And then we are adding, for the wind suction, an extra aluminum profile to the membrane, and that's the entire system. So here you see the double layers of cables, and then the external skin added via this point, and here's the aluminum clamp coming. To give you a bit of a, so this is the mock-up we built. You see the dimensions right here, the people, and you see we almost need no structure to support this. And then the membrane is coming here with the aluminum clamps on the outside. We were a bit worried of combining the PTFE membrane with a mesh membrane. So this mesh membrane allows us to generate the pattern, but also the tests have been actually much more promising than we thought. And you see the finished facade, which is super lightweight, super sustainable, easy to clean, and just very smoothly supporting the architectural vision of the architect and perfectly fitting into the context of Qatar. So as I said, how can we even be lighter than this? We can be lighter if we almost have nothing, right? So we know these wonderful plazas everywhere in the Middle East, like this one is, for example, Kindi Plaza in the diplomatic quarter here in Riyadh. In the summertime, during the day, it's almost impossible to go there because it's just too hot. So you would love to have a roof, but in the evening, then you actually want the plaza to calm to cool down. And now in winter, maybe we don't need a roof at all, right? So similar situation we had in Qatar again. So in this square, what we did is we have two buildings on both sides, 50-meter distance, and we just stressed linear cables from one building to the other, which are hanging a bit. And along these cables, we added prefabricated aluminum frames with a PVC membrane on it. So a very, very lightweight, almost like a painting frame element. They were all prefabricated and lifted up in one bunch. And then you see, due to the very reduced load of these elements, also the driving mechanism of this roof became quite simple. So you see how the roof is parked, and then we can move it out. Here it is out, and they can also be shifted over each other, and then, for example, during the peak day, the roof is here, and in the evening we move it back. And how this looks, you see here. So this is the plaza during the nighttime, for example, or during the winter time. And if you want to activate the plaza during the summer, you can move this roof out and make an event here, for example. It also strongly has an impact on the acoustic performance of this place. And another very, very lovely photo of this project. Something similar we are currently installing in the Jeddah downtown stadium. The picture quality is not so good. These are the only official images I'm allowed to use. So you see the Jeddah stadium is growing out of the Al-Balad ideas of the houses into a stadium very naturally. And inside you have the stiff roof and the retractable roof, which is now spanning 100 meters, so double the span of the roof in Qatar. And I think it will be an amazing venue when you have an event there during summer, for example, and you're closing it, or if you want to cool down the stadium before the game, and then when the game starts, you open the roof. So it's going to be an amazing effect of this building. And I'm finishing 3 minutes earlier, which is okay. Just want to say, SBP, Engineers Arabia, we are now a registered company here in Riyadh. We are sitting in a very beautiful place, right to Al Bujeri terraces. And we are happy to welcome you and engineer any kind of vision you are having for your project. If it's a bridge, a solar power plant, an artwork, or a stadium, we are here to support you on this. Thank you very much.
Thank you so much, David. It was really amazing to showcase all of these projects. And now, please let me welcome on the stage another David from Kurarai. Please give him a round of applause.
All right. So, hello everyone. My name is Davide Malizia, architectural consultant and business development manager for Kurarai. Today, as you see on the screen, we're going to talk about acoustic and sustainable products and solutions for the modern glass facades. And of course, before talking about solutions and products, we want to give an overview of what are the challenges that current facades have to face in the current Saudi environment. The construction growth in Saudi is moving in parallel into two directions. There is a big urban development of urban conglomerates that expand and take more land. But at the same time, there are non-urban areas, the rural areas of Saudi Arabia, where large-scale projects are supposed to happen or are already happening. This opens the way to two main challenges. The acoustic challenge, which comes from strong urban development that brings more people to cities, higher noise, and this, of course, requires the facades to have a better and stronger sound insulation. While large-scale projects happening in rural areas of Saudi Arabia, they may pose a threat to potential, to the wildlife and to the natural landscape in which these buildings are rising. And this opens then the way to the environmental challenge. How can we mitigate the impact of buildings and glass facades into the natural environment and landscape where they raise? Now, the products from Kurarai that are going to cover these two challenges are only a few of the large portfolio that we have. So briefly, we're going to also mention about the other products belonging to our portfolio. And before wrapping up, we're going to talk about what is coming next in the world of interlayers, where our R&D department is working on to bring new interlayers to the future market. So the construction growth in Saudi Arabia, the first example we said is the urban development, and probably the city where we are right now, Riyadh, is the best example of it. Studies shows that from the year 2000 to year 2022, the area that Riyadh took expanded by 106%. So Riyadh expanded by double. And population also increased and doubled in the same time frame, because of course, big cities always attract people that come from non-urban areas looking for better job opportunities, arguably also better lifestyle. And this brings challenges to our buildings, because our buildings need also to face higher car traffic, truck traffic that can increase the noise, and our building facades have to perform better. Now, 86% of Saudi population lives in big cities, which means that approximately 9 people out of 10 out there are facing the issues of strong noise happening in cities. So what our facades have to do to perform against this is very strong and important. If only 14% of the people are living in rural areas, nevertheless, there are strong, big projects happening already or about to happen in the near future. And as we said, the projects that the Vision 2030 is envisioning, they also want to have a combination of strong architecture and construction together with wildlife, natural environment that has to be, that doesn't have to be impacted by the new construction. So the first urban development brings the acoustic challenge. These two maps show Riyadh noise maps. The left one, where is it? So the left one is the day noise maps, and this is the night noise maps in Riyadh. So as we can see, overnight there are a bit more bluish or light green colors, which means lower dB levels, but study shows that in average, the noise level in Riyadh is always above 50 decibels. And close to major roads or highways, these levels can reach up to 70 decibels. But what do the authorities say? What do we need to achieve in our dwellings, in our indoor environments to avoid sleep disturbance, to have a better, decent lifestyle? The World Health Organization recommends in specific environments, such as dwellings and inside bedrooms, levels as low as 30, 35 decibels, which means that our facade, that are the cladding between the outdoor environment and the indoor environment, has to act like acoustic shields against the noise. How to improve the sound insulation of a facade? We basically have 3 different options. We can increase the glass thickness. More glass means also more insulation, but this brings, of course, some problems. More mass is also more weight, ideally also more installation time, and by iterating this concept, ideally is more cost. It's possible, though, to use laminated glass. Interlayers are soft elements that work as sound damping materials, and by even having softer acoustic interlayers, this effect is even stronger. Kuraray brings to the market 2 sound control interlayers, the monolayer one, homogeneous, very soft PVB material, and the multilayer one, where the soft material is interleaved between 2 PVB interlayers. Now, the multilayer is very useful when to be combined with our other PVBs, but in hot climates like the Middle East, monolayer performs way better, and this is the reason why this is the only product sold in the Middle East. This analysis shows what happens when switching from a monolithic glass of 10 millimeters and moving this to a laminate of the same thickness with different interlayers. So I'll ask you to focus on the table here on the right side. So these are the comparison of RW, so sound insulation properties, in using different interlayers. When using stiff structural interlayers like Sentry glass or Trocifol extra stiff, there's not much improvement. These interlayers are supposed to be stiff. They need to perform very close to what glass structurally does, so they don't damp sound very much. Ultra clear, standard PVB, is already helping in a way, but the magic, so to say, happens when sound control interlayers come into play and the sound insulation jumps from previous value of 33 in monolithic glass up to 38. Let's say then that we have an ideal project in which the requirement is an RW of 36 decibel. Now, monolithic glass, 10 millimeter glass, can only achieve 33 decibels, so it doesn't reach or fulfill the requirement. When using a standard PVB, it's already coming quite close, but still not fulfilling the requirements. When using an acoustic interlayer, we reach 38, which means we overdo and overcome very much the 36 decibel requirement. So that means that acoustic interlayer works so well that we can actually ask less to the mass, we can ask less to the glass. And this brings us to the last example, where glass has been reduced to only 3 millimeters, and the RW sound insulation value is 36 as the project required. Another element that I think is worth to mention in sound insulation design is the sound resonance and coincidence dip. Resonance in acoustic works pretty much the same way as it happens in civil buildings. So when a force or a stress is applied to a building or to a bridge, for example, with a certain timing, with a certain frequency, even if the force is not so high, due to the resonance, the deformations of the buildings can increase very much. And in acoustic, it works pretty much the same. So the sound wave is hitting the facade, and if the sound wave, the facade starts to resonate with the same frequency of the sound wave, then acoustic insulation is dropping. What do we do in bridges? We use viscous dampers to prevent these elements from resonating, and the same happens with interlayers. In the range between 1000 Hertz and 2000 Hertz, which is the car traffic frequency, we can see that the sound insulation for monolithic glass, which is the blue curve, drops very much because the sound wave and the glass resonate together, so the sound insulation is decreasing. When using a standard PVB, the yellow curve, it's already a bit better, but the acoustic interlayer allows no loss in performances whatsoever. The second challenge we mentioned is the environmental one. BirdLife.org reports that residential and commercial development is among the major threats to birds and volatile that are at risk of extinction. As we know, birds don't deal very well with glass facades. They don't understand reflection. If they see a light, they try to fly through it. Maybe sometimes they can see vegetation reflected into the facade, thinking it's real trees, but it's actually not. And it's very important because in the Arabian Peninsula, a lot of birds' migration trajectories are passing through Saudi in the rural areas where large-scale projects are supposed to happen. So the attention to bird-friendly glazing is increasing. The US Green Building Council, which is responsible for the LEED certification, just recently issued in April 25 the version number 5, where additional pointing is given to bird-friendly glass with a maximum trig factor of 30. What is a bird-friendly glass is pretty much what you see on the right side. So it's glazing where an interlayer with printed dots is laminated, and this is the tunnel test to measure the threat factor. So birds are let fly into a black tunnel, standard glazing on the left side, bird-friendly glazing on the right side, and the birds, of course, will tend to fly towards the transparent one. No worries, there is a net that prevents them from actually hitting the facade, but this is how bird-friendly glazing can prevent birds from flying against the facade. Last but not least, of course, the environmental challenge is also to mitigate and reduce as much as possible the carbon impact we have. And KAFD is proud to say that Transform R3 is the interlayer with the lowest carbon footprint in the industry. The products we showed so far are only few of the products that belong to our portfolio. Of course, safety products are the basic ones. Safety is a given. It's the reason why interlayer exists. All of them provide safety. But if additional performances like decorative, acoustic, as we said, structurality, but also UV control are needed, this can also be given by our products. But as it often happens, better let talk images more than 1,000 words. So enjoy the watch. Before wrapping up, we're gonna talk, as mentioned, about what is coming next in the world of interlayers, where our company is working towards bringing new products to the future market. The first product is structural acoustic interlayer. Structural interlayers are interlayers that allow glazing to go very wide and very long, so to allow projects like airports, as you see on the right side. While these structural interlayers are very stiff, they don't help, as we saw before, very much in acoustic insulation. And we want to try to bring the benefits of both into one interlayer so that applications like airport, where large glazing are needed, but also strong sound insulation is needed, the very same interlayer can bring both together. And the second one is a product we are bringing from our automotive business. It's called Skyviera. And Skyviera is a printed interlayer that works pretty much as you see in the screen on the bottom right. It's an invisible printing that can be activated by lateral lighting. So when the LED lighting on the perimeter of the glazing is off, the printing is not visible, but once the lights are on, then the printing becomes visible. There is potential no limitation to the customization of this printing, so any possibility is open for the designers. And hopefully projects like this one, where we have a very clear, good-looking skylight at night, maybe, hopefully, there will be the chance to switch from blue sky like this one, turning on the skylight and obtain such an effect. If you have any additional question on the products we presented until now or on other products, feel free to come to our booth. Thank you very much for your attention.
Thank you so much, Mr. David. And now it's a time to welcome Oliver from Seele.
Good morning, everyone. My name is Oliver. I'm the Managing Director of Seele in the Middle East. And I have the pleasure to introduce you to a new chapter of Seele that we call Kinetic. Kinetic, what does that mean? It is for us, facades are no longer static elements. They are moving. They're responding to users' needs and requirements, and they're responding to environmental conditions. But let me first introduce you to what Seele actually is. Seele is a group of companies owned by the family Seele. We have on the left side that what we are, Seele as facade design and build company for complex projects, roof and facade structures. On the right side, we have SEDAC. They're producing glass of up to 20 meter by 3 meter 60. We have Sunglass that belongs to SEDAC, where we produce any form of curved glass, cylindrical curved glass, conical curved glass, but also 3D shaped glass. And last but not least, we have Seele Pilsen, where we produce any form of architectural steel. All these companies are independent companies, so we as Seele can go and buy glass from SEDAC, but we can also buy it anywhere else. It's just the same owner. The same way anyone in this room can go to SEDAC and can buy his glass from SEDAC. So we have offices globally, head office in Germany and Europe. Here in the region, we are based in Saudi Arabia and in UAE. These are the projects we are normally aiming for. A project for Seele is usually a complex steel and glass structure. They are complex membrane structures. Unitized facades, though we don't do unitized facades here in the region, but we are very strong for all glass structures, like a project that you can see here on the right, Apple Store in Abu Dhabi. These some project reference you can see here. On the top left, wait a second, top left, Chadstone, a shopping center in Melbourne, Australia. It's a complete freeform. Maximum span of the grid is 44 meter. For me, quite impressive. You can see in the middle a glass bridge. It's hanging at the facade, only at these two brackets that you can see, 11 meter cantilevered. I had the pleasure to stand on it myself. On the top right, you see also an all-glass project, 16 meter high glazing. So what my predecessor just said, this big glazing is possible with his interlayers. 16 meter high suspended hanging structure of glazing. On the left, a project that probably everyone in this room knows is ITRA, King Abdulaziz Center for World Culture. Also a complete 3D shape, freeform, 350 kilometers of stainless steel pipes wrapped around the facade. Apple Cube Fifth Avenue in New York, and the Sphere in Las Vegas, a project I will come to you a bit later to you. Opening now a new chapter of Seele is Kinetic. We said Kinetic is looking into movable facades. We call it Kinetic with IQ. What does that mean for us? Kinetic is looking in any form of movable parts at the facade. Pivotal facades, meaning facades they're rotating, turning around the axis or a specific point, but also any form of gliding, shifting, sliding, or extending facades. That means they are moving linear on a defined track. These are the sort of the two main principles of kinetic, and these are the forms that dynamically reacting to users' needs. What is kinetic specifically doing? We're looking into outstanding drive technologies, smart control systems, of course safety concepts. Whenever there's movable parts involved, we know there's a strong focus on safety. Safety concepts are important, usability and interfaces, but of course also water and air permeability and acoustic performances. Kinetic is now merging the typical Seele projects with an outstanding design with a strong focus on precision and structural engineering, merging these two chapters, and we are moving architecture forward with it. Let me now come to a specific project, a project that we finished in head office of Apple in Cupertino, California. Foster and partner were the architect. Imagine the safety requirements for a sliding door and now transfer this in a completely openable facade. We're looking here at big sliding doors, mega doors. They're opening completely and opening the internal restaurant of this campus in Apple and making it one space inside and outside. These big mega doors you can see here in a video are measuring 16 meters in height and 28 meters in width, one sliding element. So they're opening completely on a curved track. And you see immediately, for safety aspects, the rail they're going on is concealed, and all the safety aspects are considered here in that movable part. Also, of course, air, water permeability. But what if with these 180-ton movable doors, we have a power outage? Also, this was considered in our design. You can, in case of a power outage, move the whole facade with a simple cordless drilling machine. It is possible. The next facade is also a completely opening facade. At this time, it's upward lifting. It's a project in London, UK, and you see here a 10.70 meter high glass door, a 10.70 meter wide glass door opening, 2.20 meter height. Again, is opening up the interior and the exterior and building one environment. 10.70 meter is one glass panel. There's no transoms in between. The whole thing opens in 2 minutes. It's an electromechanical drive mechanism. What's important to mention, we also, of course, have to comply with all the statutory regulations in UK. We have implemented an active pneumatic sealing system. That means the moment the facade closes, the ceiling is inflated, and the moment the facade is opening again, the ceiling deflates. One other project that we finished in 2023, the Sphere in Las Vegas. Architect is Populous. You will probably ask, what has Seele to do with that project? The external facade was not our part. Our part was the internal LED screen. Internal LED screens means there are millions of LED tiles at the aluminium frame and the substructure. That was our scope. And again, why Seele? The answer is in this picture. You see on the left-hand side, the client implemented several mock-ups. The left-hand side, you see the hairline joints, and you see every single panel of the LED screens. And this is exactly what the client did not want to see. He wanted to see a seamless picture. To achieve this, we had to work towards tolerances of 0.5 millimeter. We all are from construction industry and know that 0.5 millimeter is a tolerance you don't find usually in construction business. These are rather car manufacturing tolerances, but these are the tolerances we had to work through to achieve this. It started from the manufacturing process. We had to manufacture the profiles under condition 23 plus minus 1 degree. We had to measure the temperature in the construction facility, in the production facilities every 10 minutes, and depending on the temperature, we had to change cutting sizes of these profiles. We had to maintain this condition during pre-assembly, and even for the final installation, all parts were brought into the sphere itself. The building was closed by that time. AC was running, and only after 24 hours we could install the final elements to achieve this 0.5 millimeter tolerances. Your question will now probably be, what has that all to do with kinetic? You will see here. Inside this big LED screen, client wanted to have a so-called proscenium screen with a total opening of 30 by 15 meter. This screen serves the purpose of bringing in trucks, removing old stage building and bringing in new stage building. This opening has to be fully demountable within 24 hours. And of course, after reinstallation, we had to maintain the tolerances of 0.5 millimeter again. So that means for this temporary structure, we had to invent a very innovative locking mechanism to maintain this 0.5 millimeter. And even for the hoisting of these elements, we all know that lines at the sphere are not parallel. That means when you're lifting up these facade elements, you need to consider varying distances of the rail and need to integrate this in the rails or in the wheels gliding on these rails. That was achieved by a spring mechanism adjusting to the width of the rail. Here you see the shear open or the shear size of the opening. All these 6 transoms that you see here are completely removable so that you have the full width of 30 by 15 meter inside the overall screen. Another movable part in this project, I just want you to see it closing. You see here a seamless picture. Again, we had to maintain 0.5 millimeter tolerances. We had to install 200 of these rigging hatches. A challenge here was, of course, the tolerance again, but also their opening during a show. That means they need to run very quietly, opening in a short period of 15 seconds. They're opening, for instance, during a show, drones are flying in, or stage equipment will be let down in cables. So 200 of these rigging hatches were also installed in this project. Next one is a project for a private person. We can't show many details of it because it's confidential. It's a drop-down facade that's completely disappearing. But I think the animation itself gives enough information. You see the entire facade element is moving downwards into the basement, and left and right, the guiding rails, you see the moment the window disappears, the guiding rail is completely concealed, and once the window is open, you don't see anything of the facade element, it's completely invisible. Again, opening up completely the internal and the external to give it one big space. For this project, we had several facade elements. The biggest one was 14 by 11 meter. It is opening in 6 minutes, weighs 30 tons. We had to undergo 7 different tests for that project. The standard tests like water performance, air tightness, acoustic test, but even a hurricane test we had to do for this in line with the regulations in Florida. We had to do this hurricane test. So the next and the last project brings the whole movement part into the next level. We have here a project that we are currently executing in Oxford, United Kingdom. It's a cancer research institute funded by Mr. Larry Ellison, the founder of Oracle. Architect is Foster, and what you see here is a dome and a dome. The internal dome brings in the daylight, is a complete timber and glass structure for the lighting of the interior. But what's the trick is the external dome that is circulating around the internal dome, following the path of the sun. These louvers that you see here are giving the shading always on the side towards the sun, while on the other side you have permanent daylight coming into the building. And even the louvers can be adjusted depending on the season. We can change the angle of these louvers. This entire dome has the outer dome has a width or diameter of 19.7 meters. It weighs 80 tons, and for full rotation, it would need 10 minutes. However, we measure half-hourly the position of the sun, and based on the sun, it is rotating 24 hours, 365 degrees. It is driven by 4 gears. They're looking like this. You see the rail on the left-hand side, and this rail is driven by these 4 gears and rotate the entire dome around the internal dome. Yeah, with this, I'm at the end of my presentation. I hope it was not too boring for you. If you have any questions for the projects that we presented or for your project, we are outside and we are happy to entertain you. Thank you very much.
Well, thank you so much, Oliver. That was really amazing. And thank you, all of you. Thanks for all of you. Now this is the last speaker in the first session. So now it's the time to enjoy having a cup of coffee or tea and for this kind of break, and don't go away. There's another session.
Good afternoon. I remember 20 years back at the university, all the engineering students on the campus were busy with their formulas and textbooks, except the architects. The architects, they had their huge worksheets, their pencils, their tracing papers, and their models. They didn't simply design projects, but they had ideas. They imagined a world that didn't exist. But with this imagination, the challenges comes. The challenge is how to bring something imaginary and make sure that it works in the real life. How to protect this imagination against external forces like wind, water, fire, time, and cost. And here comes the purpose of Effisus. The purpose of Effisus is to make sure that we protect these buildings against these external factors. For the last 2 decades, Effisus weatherproofed more than 3,700 projects in the globe. So we are talking about all the continents, different countries, making sure that we are excellence in weatherproofing. And when we say excellence in weatherproofing, here we talk about excellence. It comes from where? It comes from disruptive innovations. When we say disruptive innovation, something that changed the game of weatherproofing. And we talk about global recognition and awards worldwide. Since 2011, even we increased the focus to look further at non-combustible solutions due to the fact that there are many fire incidents that we have seen in the past over the last 20, 30 years. And when it comes to key solutions that what we provide, we are very focused and niche. We look at applications for the building envelopes, weatherproofing of vapor, water barriers, and the interfaces or the weak points, I could say, from joints or flashing details. But why this matters? Why the weatherproofing or the airtightness matters at the project? Here I want to take you through some data about the Saudi Arabia basically, but even it's applicable worldwide. If we look at airtightness or let's look at the performance issues in the buildings, it's majorly linked to the building envelopes. In Saudi Arabia, as an example, 47% of the cooling energy is lost directly linked to poor airtightness. And when we look at the projects, we are talking about 80% of the projects which face water leakages. This is back to the air tightness part. The air tightness part, building air tightness failure rate, we here talk about 65%. And from this 65%, what's the result? The result is having for around 40% of the occupants suffering from sick building syndrome. If you search up sick building syndrome, you will find out it's due to many factors. Part of it is the mold growth inside. We face different symptoms of coughing, of having respiratory issues. And also on top of that, when we talk about CO2 emissions, building envelopes contributes 18% to the country's CO2 emission, and this is huge. That's why we need to look carefully when we talk about weatherproofing. And it ends up with a loss. Basically, we are talking about 10% roughly project value loss due to that. So the importance of weatherproofing is not about energy saving. It's also related to health issues, to having a proper indoor environment. It's also to meet the climate and sustainability goals of Saudi Arabia. In addition to that, another important factor, which is the economic impact. Here we talk about billions of Saudi riyals, which can be lost due to cumulative costs, facade, basically water repairs, issues related to air tightness and water leakages. The assets basically accelerated, and the depreciation is around 24%, and that basically increase the life cycle maintenance cost of around 49%. By default, the insurance premium also increased to 65%. What happens after that? It happens that the new tenders, the expected increase in the tender prices is around 10%. So all these values matters on top of the energy saving, on top of the health issues. So what is the main problem? The main problem is we thought, okay, it can be a skill issue. No, it's not. We have the right skills. We have the products. We have innovative products. We have designs, beautiful designs. But we have a problem in the coordination. So there is a coordination gap, what we have seen on the chain. So if you look at this chain, in any project, let's say a developer or a client, he thinks to build a 5-star hotel. Okay? He's looking at the big picture. He's not looking at the details of weatherproofing, as an example, or air tightness. And here we have the ambiguity between the developers and the consultants. At the time of consultants, we have seen that some of these details may be overlooked. Some of these details, maybe they didn't have a proper look at or awareness of the weatherproofing codes. And we go further in the chain, We have the project management team, the contractors, the subcontractors, then the manufacturers, suppliers. And imagine every single detail missed on each step, that will end up in a 1 million Saudi Riyal problem. So in Effisus, we decided we need to break this chain. So we need to stop this and try to be at much earlier stage. So we have developed what we call it an Effisus framework system to break the cycle. So the Effisus EFS or Effisus framework system, it's very simple. Here it's having 3 components. So 3 components, engineering the invisible. What do we mean by that? Is the proactive planning at early stage from the project. And that means working with the consultants, with the architects at early stage to make sure that those details are not overlooked, to make sure that all those small intersections between trades is maintained, to have a proper performance for the weatherproofing. The second part is fortify the interfaces. What we have seen, that many challenges happens when you have multiple interfaces between or intersection between trades. When we talk about trades here, we refer to civil engineering and HVAC as an example, or aluminium and civil engineering. And we see this at the projects every day. At the time of design, it's beautiful in the drawings, but at the time of execution and the construction, the issues happens. Third part is to link whatever happened at the design stage and take it to the construction with our team where they are there at the construction site to make sure that design is basically connected at the execution part. Some of you might think, okay, can be theoretical, but we have seen the results of this for the past years. The results of this is some examples which I'll show here, like worldwide, not only in Saudi Arabia. As an example, Google Treasury headquarters in Ireland, where a lot of coordination happened at that early stage to make sure the details and the intersection between the HVAC contractor and aluminum contractors is maintained. Those small details are very important. Another example here, a living lab in Portugal. Here we talk about a modular system where an early stage coordination were required to make sure that weatherproofing performance is maintained. In Saudi Arabia, there are many examples, but one of them is the Red Sea Marine Life Institute. If you look at the details, it's complicated. If it was not properly coordinated at early stage, it could not happen at the execution time. And when we say details means it's even a small screw. It can make a problem. Because at the end of the day, when you talk about waterproofing or weatherproofing, you look at the weak area, you look at the small point. That small point, if it's not proper, if it fails, that means the whole waterproofing system doesn't work. Another example from Riyadh Metro Station, KAFD also. Similar application that was designed by Zahadid, and coordination happened at the early stage, where at the time of execution, also the team were there to make sure that it's matching. So we break the cycle. Furthermore, Triple Bay Yacht Club. This is one of the unique projects. It's a beautiful architect, but from the outside. But if you look at the inside part, where the weatherproofing, where the intersections, the steel columns, the HVAC applications. So all of this has to be looked in details at early stage. And the list go further and further and further. If you look in KSA as an example, or even the region, those projects, at some point of time, they were sketches, they were imagination. But if we look now, it's reality, and we can see it live. But without a proper coordination for that particular area, the air tightness and weatherproofing, we couldn't reach to that performance. Effisus is not about delivering projects. It's recognized for building legacy. We are collaborating at early stage with architects, facade consultants, but not only that, we also collaborate with government entities, with laboratories, with standards organizations, and sustainability code standards. So you remember those students at the university. Those students, they are still imagining. They are still pushing the boundaries. But the world has changed. We have harsher climates. We have sustainability is essential now. Even the projects, it became more complex and complex. And here becomes our job at Effisus to protect this imagination against those external factors. So, ladies and gentlemen,
where is that thing? Good afternoon. Good afternoon, audience here in Riyadh. Nice to be here. My name is Eric. I'm Eric Claeys, and I'm the founder of the group Façade. As you see at the color of my hair, I'm quite some time in the business, more than 40 years. And I think it's good to know what I'm going to say, that you know a bit of my background. I'm a civil engineer in construction. I'm a civil engineer in building physics. I'm an economist, and I'm a banker. You know why I'm saying you this? Because it's all about money. All we do is money. The group Fassada, we are present all over the world. What is the reason of our existence? The reason for that is simple. And it's very clear. My colleagues, if you can call them colleagues, they did only one thing the past 50 years. They slept. And the only thing they did on their systems is copying each other and even copying the stupidities. It's bad to see. I see it all over the world, from Sydney until Seattle. But there is a second reason. Did you know in this business that facade contractors go faster bankrupt than they can start all over the world? It's even a joke. In this kind of business, facade contractors, mamma mia, is the excellence of amateurism, sorry to say. So I took the initiative about 25 years ago to write a book about it, a whole study, and then to start to develop something. Developing something from a completely different spirit. We have to think that these products, whatever you call them, curtain walls or whatever, unitized, whatever, at the end they have to be fabricated and installed by labor. The key chance for the coming 500 years, not to say. What does that mean? It has to be simple, and even the most simple thing is too difficult, and even if it is too difficult, it can never work, and if it is too difficult, it's too expensive. So what did we do? We developed what we call a technology, it's called hybrid. I just heard hybrid. It is not a stick. It is not a unitized. It's something in between. And why it has to be in between, it just happened like that. The whole technology is patented, protected by 800 patents worldwide. 800. It's good to know. Because people, they have to know that they need to think their brains instead of copying each other. And we don't laugh with people who try to do that. Façada steel is one department, is one pillar. We have a pillar aluminium, a huge pillar, by the way, for people who think that we only do steel facades. We have the steel facade. And why is steel? We developed the steel principle with the steel facade with the same weight as an aluminium one. Can you imagine? And why did we do that? Because the market is asking for it. It's the only curtain wall who is fire resistant 1 hour, and all what we say, sorry to say, it's bullshit. In this business, they call a lot of bullshit. But maybe let's start with this. I see it every day on my desk with projects all over the world, that people don't know the basics of our business anymore. What's a facade? What is this? Can somebody help me with that thing? That thing here? Yeah. What is a curtain wall? We're speaking here all about these nice things. What is a curtain wall? A curtain wall is an envelope around a building. And that envelope is made by a structure and some infill elements. And that envelope is fixed to the primary structure. And that whole envelope is defined by two sciences. Building statics and building physics. Most of the people even don't know. Building statics. It starts with the law of Newton. You know the law of Newton? The law of Newton is the famous law of gravity. You see here this apple. And what is the law of gravity saying when I have here this apple and I open my hand? What's going to happen? Lots of architects think it's going to float. It falls down. I see people laughing. I see every day on my desk designs where people don't understand this. On top of that, a building is not stiff. It can be concrete, but it moves in every way and differentially. They don't understand it. And they want it to be solved by a stupid aluminium grid in front of. How dare they? Secondly, building physics. Is the skin around your building? How many people here in the audience even thought about that this would have the complete impact on your mechanics of your building? Did you ever think about? My office building cost nothing. It is a phenomenal building. It is a solar plant, a smart facade skin. The energy generated is much more important than consumed. And the income revenue by the sales of my energy is more than the finance cost of my building. That's what it should be. curtain walling. That's what it should be, money. Our patents. For the steel, I'm here for steel. We made a joint venture with the #1 worldwide. It's a group Montan-style based in Switzerland. Program of my presentation, don't look at it. I'm going to speak a little bit about other things. This. Engineers should understand this, otherwise they don't have to engineer. It's all about this. And here in your countries, your region, they even know it much better than others. And this here, innovation is good. No. It should be disruption, because the whole business has been sleeping 50 years. I'm sorry to say that. And I hear it every day, I see it every day, what I see, to get mad of. That's a stick system, a unitized, I don't go in detail. The guy who developed this, I know him. Fancy, in Italian, I know him personally. The guy who put him on the market, Mr. Massimo Colomban, the pre-owner of the group MST, I know him very well as well. What he didn't do, here, you have here some negative USPs. By introducing this, big problems. High material cost, astronomical transport cost, pre-finance cost, high storage cost, lots of problems. One of the main reasons that these companies go bankrupt because they don't have the pockets to work with unitized system. We solved this in the technology we showed here over there. Steel, some USPs, 10 times less carbon footprint, but that's not important. I'm going to say it's not important. And all the rest, steel is green, fire resistant, whatever. What is the main thing here? About here, carbon emission. Sorry to say, and lots of it don't hear, the kind of crap I hear every day is shocking. Green products. Stop that nonsense. This here. Oh, what did it work? Oh. The embodied carbon is good for about 20%, and that's in your product. But that's not the key. The key here is your operational carbon. Operational. And this operational carbon comes from your skin and from the consumption of energy for cooling and heating of your buildings. Did you know, by keeping a bit of sun out, and for sure here in your countries, that you could reduce, but of course you don't have the teaser because the energy is here very low cost, that you could reduce your consumption by about 50%? This means here, that's an envelope. Think about the basis. That's what we need to solve. Solving this problem of secondary order, this is the key. This we need to solve. And all the rest is greenwashing. Small facade. Green building. Sorry for the term, the biggest shit there is. That's an energy monster. And that building has a BM gold facade. Hypocrisy to the highest degree. These guys, they even never understood the basic building physics of what we call a greenhouse effect. When sun comes to light, it is absorbed in surfaces and then it is reflected. How can you talk about a green building in a glazed building? Nonsense. That's how they do it where they don't have money. I didn't say you have to do it this way. But this is the proper way to do it, to make here a sustainable building, and that's a catastrophe. What to do? Stainless steel. Maybe for people who are interested, with steel, this means also stainless steel, titanium, and which gives you, in aggressive environments, 100 years of guarantee. And again, 100. Circularity. Another topic. The best is no circularity. It's nonsense. Sorry to say again, it's nonsense. What is the best car from the perspective of circularity? Gonna help you. A Porsche 911. Porsche 911, the first came to market in '63. Now even 74% of the cars are in use. This means there is no circularity problem. A Porsche is not a disposable product, a Façade neither. But there is another problem. The grid, that's good for about 50 years. Not your infill elements. And on top of that, in Europe, it is mandatory to follow the regulations. What's constructed now in 2025 will be old-fashioned in 2035. You need to upgrade this. How to do this? Unitized systems. You can't. Structured glazing. You can't. Unless you dismantle the whole building. In 2 days, I will give a presentation in Mumbai for a whole group of developers. And I'm going to show there were figures that the challenge of the Green Lead, of the Green Deal, is fantastic for as well the developer as the final owner to make money. But you have to think out of the box. So the only way to do this, when you do it from inside glazing, upgrading, and we have there, for the low cost, we have the monopoly. Shorter execution times with unitized system. It is just not true. Because here you have a huge, for unitized system, time needed for your fabrication, and this costs a fortune, and by the way, implies a huge pre-finance cost. Low-skilled workers, it is key. To give you some idea, we are opening now shortly in Ningbo, the south of Shanghai, in US, in Kentucky, and also in Stabio in Switzerland, dark factories for curtain walls. A dark factory means that there are no people involved anymore. We have nothing against people, but we prefer to have a consistent quality. This means the human factor has to be out. So this means these curtain wall factories, they are completely robotized and with androids, and with not only with a double consequence, that the consistency of quality, and the quality, it is 24 hours a day. It is guaranteed, but on top of that, I just spoke to somebody here from a big Chinese company. We could reduce his production time by a factor 30. Not 30%, 30 times less, from 100 to 3. Not the concept. Again here, it's all about money. Low-skilled workers, minimize risks, that's key. One of the main reasons why all these facade contractors, they go bankrupt. And I think we should, with all of the people here involved, it would be nice if some of people at least would be aware that the whole challenge of that Green Deal, that it is a money maker and not a thing that costs money. And not about return on investment calculations. Then your design is wrong. It should from day one be better, lower cost. But unfortunately, you cannot do it the standard way and with conventional systems which have been developed 500 years ago, at least 50 years ago. External claddings, all installed from inside. That's the way to keep the sun out. It's a must. There are many ways to do that, but you can do it in a very efficient way. This here, we solved. I solved this. In our buildings, impossible this happens. And it's a must. No, it's our duty to do this. It's our duty to do it, and not the way they do it in UK, unfortunately, all the regulations. We know how to do it. They have to do it in a proper way. You know the thinker from Rohde? Before you do something, we need to think. And then you do, to last. That small guy there, he will be launched in a couple of months. It will be kind of like a Michelin. It will be our mascot. And it will explain on LinkedIn all the buildings we are involved in, from Seattle, west of US, to New Zealand, east of Australia. Thank you for your attention. And again, there was a goal. I said you have to do it. Maybe you can going to learn something. I hope I was okay, and if not, you can tap on my head.
Okay, thank you so much, Mr. Eric. It was really an interesting presentation. And now Let's welcome Agnes Koltay. Please welcome on the stage.
Thank you very much. I am Agnes Koltay. Welcome everyone here. I will talk about a project that we are working on here in Riyadh, so hopefully it will be interesting. Koltay Façades is a facade consultancy company. I have been living in the UAE since 2005, and I started the company in 2011. All these years we managed to open more offices, Singapore, we have presence in London as well, and we're very lucky to work in worldwide projects, many worldwide projects. Some of them are here in Saudi. 2013, I had involvement in Kapsark. That was my first visit to Riyadh, second visit to Saudi. Some of our projects, we did some very experimental, very interesting, unique facade systems for projects like Museum of the Future or the Opus building in Dubai. Have been working on a couple of museum buildings because museums are typically the public buildings which want to be a bit unique and a good place to nurture interesting designs. So the building for today is the Art Museum in Misk area. And we got involved at a very early competition stage. We got this call from a small architecture studio, Studio Anne Holtrop from the Netherlands, but living in Bahrain and having a studio in Bahrain. And they have a special interest in textures, material textures, so much that in his workshop, Anne even has an area to cast materials and experiment with surface structures. So this is the background how he came from, and then he got some inspirations from carving stuff into textured rock like Hegra, and having this very interesting textured rocks formations sticking out from the landscape, like the edge of the world nearby here. And then we came to try to solve these problems, to try to give texture to glass and make it stick out from the landscape. So this is the competition design. Textured glass cube sticking out of the landscape, connected to the upper tier of the Misk city and hanging into the body. I can show it on the cityscape model that Misk had on cityscape. It's a large valley. I'm sure many of you familiar with the site or went there and visited before, and you see illuminated in yellow the Misk Art Museum building, which will be really a focal point of this development. There are other interesting buildings here. We are working on ILMI, this globe, it doesn't have a pointer, the globe, kind of glass globe thing there, or the triangular shaped foundation building behind. Okay, so let's get into the design. So the idea was to stack these cast glass pieces, these textured, very heavy pieces, and build kind of a, not really a pyramid, but like an inclined facade out of it. And this could provide also a very nice filtered screen light into the exhibition space. So we have very tall, very high floor-to-floor height spaces for the art pieces, and this nice soft light is very ideal for the exhibition. On the other hand, it's not airtight, watertight, so there's a second skin, floor to floor. You can see it here, and that gives some climate control as well as noise control and the aesthetics. let's have a look at the elevation. So now you can imagine these glass panels. They are large. They are typically 2.3 by 3.8. We have a column spacing 2.4 meters, which means not every panel can be directly supported. I will get back to this point. And then they are overlapping, 100 to 200 millimeters, and they are very heavy. That's what we know about them. Designing the frame for them, the support system, started out from this knowledge that they are very heavy because we don't want to hang them on the building. The building structure, the concrete, is art in its own. If you look at it, I think it's beautiful. But it's not, it can be only this beautiful and this columnless, supportless to allow for the large art pieces if the heavy facade is not loaded on the structure. So there will be two framing, one of them to support the internal facade and then a separate one to support the external cast glass facade. The internal one is an easy one because it's just a flat, very simple stick system build-up. It was intended not to have vertical mullions, so basically two sides supported plus the joints. These columns are placed from the outside floor to floor, like from here to there, and then the glass is attached from the inside. This gives the actual airtight, watertight enclosure of the building. And then we have the external, these are some construction images, so you see the glazing and the support. And then we have the external facade, which is loaded on a very separate strip foundation outside of the building, directly to the ground. And the whole facade is supported by steelwork, originally stainless steel. It ended up not being stainless steel, but still quite nice. We wanted to step the steel to follow the architectural language of the cascading facade. And you can, here you see the separate foundation and how it allows for a columnless interior. And this is what I mentioned, that because the column spacing is 2.4 and the glass is stepping in every direction, not every glass panel can be supported properly onto 4 points. If you look at this piece of glass, it has 4-point support on the 4 corners. This is, this here is the column. And then this here is the next column, steel column. These two pieces, this piece in the middle will need to will need to link the two pieces. So, if you look at I think I'm too close. I'm not sure if I'm pointing at the right place, but every second panel is. Every third panel is supported for 4 connection points, and in between they only have 2 connection points and link together. Yeah, so that's the structural idea. This is the current, not current, a few weeks ago situation on site. So you see them getting built. Let's talk a bit about the glass design, and then I will circle back to the structural concept and how they come together. So at the very beginning, we considered some design options. It could be normal architectural glass. Maybe they can be in layers and slammed into a mold. Maybe it could be a poured cast glass, or maybe it could be just a big block of glass and CNC cut this pattern out of it. The third one was immediately rejected by the architect on aesthetical grounds. It just does not give the natural feel of the texture. And the first one technologically cannot provide deep enough differences in between peaks and valleys in order to have a meaningful texture in such a large scale. Yeah, so if it's a small piece of glass and you are close by, it's a very nice texture, but from a distance, it has to be a much more emphasized texture to give you the view in the aesthetics in scale. Borosilicate glass came in the picture when we started talking about cast glass, because it's a material which is easier to work with, and it has additional benefits. It has very nice optical qualities, does not have the greenishness that soda lime glass has. It's actually even clearer than low iron glass, and has very good thermal shock properties, so it doesn't crack on. It's basically they are using it for fire applications as well. This property is extremely useful in a climate where the temperature can reach high values. The actual difference in between soda lime glass and borosilicate glass is in the ingredients. Obviously, soda limes has lime and borosilicate has boron. This is what I mentioned, so it has high resistance to thermal shock, which is very, very useful in our application and in this climate, and it has extremely low iron content, very nice visual qualities, which is a pleasure for the architect and for the visuals. What it does not have is good cost and low price. It definitely does not have. So it took some efforts to actually implement it in the project. So we ended up with the open pour, and this is one of the first mock-ups. These images are not samples for this project. These are just other images, but it's an existing technology, and they are using it for mostly artistic applications. In architecture, it's mostly used in interior design or at smaller pieces of the facade. I'm personally not aware of a whole building, especially in such a large scale as our art museum, to have been built with fully cast glass. So it's quite a first in history. And that gives a special type of excitement for facade engineers. And obviously it also needs a lot of research and experiments. And if something is first in history, you may expect things to happen the way how you expect it to happen, but you know that it may not be like that because it was not tried before. So anytime when anyone wants to build something which is interesting, new, pushing the limits, it has to be accounted for that there will be some research and trial and error cycles in the project, and it's pretty normal, and it has to happen that way in order to gain a safe end result. So that's what's happening with this project. We assumed for the design a certain, okay, let me just explain a bit about the texture. So I explained that the undulation of the surface has to be quite emphasized in order to notice it from a distance. So these are the final numbers we ended up agreeing with industry and the architects. The cast glass is laminated with another flat sheet of borosilicate glass. The cast glass, because it has the uneven surface, cannot be heat tempered, although the flat glass which we're laminating it will be heat strengthened. And that provides additional strength, and the lamination itself, the laminate material, will provide better post-breakage behavior if anything happens. The undulation you see is like 43 millimeter peak locally and 35 millimeter average. The technology to cast it is the open pour technology. Borosilicate glass gets molten around 1500 degrees. They pour it on a steel mold. It's very interesting how this steel mold is prepared. I will show it. After that, it goes to, it needs to get flipped and released from the mold, but then it spends an additional week, 6 days in the annealing tunnel, and it gets annealed. This is the mold production. So the first step is setting the pattern itself out of clay. This was an exercise that was done together with the architects, and basically hand mold the pattern. We have 20 different patterns for the whole building. Hand mold the pattern until each portion looks nice. They actually modeled it first in Rhino and then did a rough clay mold sample. Then they put those scanning points, scanned it in, compared to the Rhino model. That was the process, an iteration process. Then on top of this clay, a foam is poured, negative, and then it gets turned around, and a resin, sand resin layer is poured on top, which will become the positive mold for the steel. So then the steel gets poured on, and they take that off, and that's the final mold, which will be used for casting the glass on top. Very important that the design should not include negative zones, because then the glass cannot be released. So again, this is a very long process, even after you have in the computer your pattern to make it into a real mold. It's quite an interesting process. These are the steel molds and some early samples. And now let's talk about the glass strength. We are circling back into how it becomes a whole building. I have to say that we assume that annealed glass will have the strength of annealed glass, and that's around 45 megapascal for normal annealed glass. And we expected it to be a bit less, but not too much less. And then the first tests happened. Even to do the first tests needed some creativity, because if you do the 4-point bending test, and that's why I put the question marks there, we try to do it according to standard, but the standard assumes flat glass. It does not assume this undulated surface. When you start doing the test, obviously it's not gonna show a realistic result, because the glass is loading on certain concentrated points and not evenly. So to overcome that, yeah, we considered it, flipping around. But anyway, if you are not having the contact point here, then you have the contact problem there. At the end, it got tested flat surface up, and we tried to put like a rubber mat to even out the load. Didn't work very well. They 3D printed an exact negative to put it there. It didn't match exactly. Then we put the rubber in between. That worked somewhat, but it's for every sample it's a different stripe, actually 4 stripes. So it would have become extremely slow process. So at the end, the way how we're testing them is grinding it back and provide the surface that way. Interesting breakage pattern, just to show you how it breaks like annealed glass. If you try to zoom onto or enlarge the breakage pattern, you see these little bubbles, which an unfortunate, not unfortunate, but this is how open pour is. It comes with some bubbles. There are technologies to reduce the number of bubbles, but it's still a very manual technology, and there will be some bubbles. You can imagine that an air bubble in a homogeneous material is not something that would help the strength of the material. So we suspected that those bubbles are mainly what's weakening the glass below the annealed strength expectations that we had. The factories were trying to improve this. Meanwhile, we figured that a second factor comes in. When they cut the big pieces and they cut it to smaller pieces to do the test with it, actually the way how they cutting could also impact the strength of the glass, could basically cancel out more strength than we would like. The next problem, things that you don't really think of when you are doing the schematic design, but then, of course, these problems are coming. You cannot even do a proper stress reading on the surface of the glass. This was one of the ideas to kind of grind back certain peaks to provide a horizontal reading surface for the Sculpt machine. At the end, it got solved differently, but Sculpt as a company got really involved and helped a lot and worked with the laboratory, which is in Germany, to find a way to get a reading out of the undulated glass surface. We had a thermal shock test as well, and as expected, this is this is something where the tick is given. There were 3 different tests. Each test had 8 samples. We went to 72 degrees, 82 degrees, 92 degrees, and there was no breakage, no failure. The borosilicate glass is very good for thermal shock resistance. So let's get back to the framing, as I mentioned, because when we did the concept design, you remember this one, we wanted to minimize visible steel connections. So to give this really nice textured ice cube-like of surface that the architects designed. But we assumed the strength of annealed glass. And as we see from the experiments, the actual borosilicate cast strength is below the assumptions. So we had to modify the design a little bit. First of all, in the original design, we wanted to drill through the glass, and that's because there are, you remember I mentioned that there are sometimes 2 pieces of glass which is linked together, and they only have 2 support points. Even if they are linked together, they can still rotate. So to stop that rotation, we wanted to have not just a clamp support, but a drill through bolt. Around that bolt hole, the stresses would peak. It would be a concentrated stress there. So when we are working with a lower strength glass, this is the first thing that we have to eliminate. So first we tried to put 2 bolts to share the load a little bit. It was still overstressed, as you can see on that image. And then we ended up providing a third support point for those pieces of glasses to stop rotation, where only 2 support points was given. And the clamp remained without any through bolt, just a clamp, as you can see here on the bottom of the screen. I show you the solution for the third point. So you see this piece of glass is not at easy reach of that column, and it has to be a bit of outrigger to pick up this point. So we always, for each piece of glass, we always find the closest column and tie it back there, which is a must because of the structural concept and safety. But you see how the design needs to accommodate these findings. Also, a bit of modification on the interlayer. Originally, we specified SGP interlayer. SGP has, it's a very stiff interlayer, you know. And when the two pieces of glass is laminated together and the soft SGP cools down, actually it pulls the glass together and puts a residual stress, tension, a pull force into the glass. So again, this is something that, because the glass strength is lower than expectations, we wanted to avoid. So we don't need the SGP for strength. We have 80 millimeter glass. It doesn't need more rigidity. We could have gone with PVB, except the edges of the glass is exposed. So we ended up switching it to a Soflex DG41 structural PVB, which can be exposed and less stiff than the originally intended SGP. That's the current status of the project. Right now, as we speak, there are 80 more samples getting tested to get the exact values, stress values of the final production. And the rest of the structure is built on site. The framing is mostly completed. The internal skin is completed. We are waiting for the glass, and I don't know, see you at the opening of the museum, hopefully very soon. Any questions? Okay, thank you very much.
Thank you so much. It's really interesting how you really use this material in this building and showing this looks, which is really cool. So thank you so much. Now we're looking to the first panel discussion in this event, which is will be moderated by Filippo from Zaha Architects.
Good afternoon, everyone. Thanks, Faisal, for the introduction. I am Filippo Innocenti from Zaha Architects. I've been with the company for about 25 years, and I had the pleasure and the honor of being the project director for the KAFD metro station in the financial district. This has been quite a significant project that represented a lot for myself, but also for the whole office. It has been an accomplishment, milestone for Zaha Architects. So I thought I was sharing my experience today with you, inviting in the panel those same dear friends and colleagues who have joined me in the same journey. So first and foremost, Mr. George Kanj. George was, please come. George was at the time, oh, you can see here. At the time, George was the deputy director for the whole metro project at BAX and is now vice president at Al-Mabani. And then Mr. Azat Tatigulov, a young engineer at the time, now associate at Bureau Happold. He's been part of the structural design team. Mr. Mark Storm from Permastelisa, the design manager who's been translating the design direction into fabrication. And finally, Mrs. Rawan Alderjem Aldusari, who has shared with Zaha the design development in our office, initially working for Bechtel and then being part of this invaluable office of site supervision. So, welcome. It feels a lot like one of those design team meetings we had recurrently for years during the design development and during the construction. This is a project that represents a lot to us, in particular an accomplishment for Zaha Architects. It's the second building that we realized in Riyadh. after the CAPSARC. And is a project that at the time, as a brief, when we did the international competition in 2012, had the mission of becoming a landmark to represent the ambition of this incredible infrastructural project, which is the metro of Riyadh, something that has never been realized before, a whole network of metro to be built and designed from scratch. So, well, I mean, projects like this one require quite significant engagement personally. They require people to work together. It needs a lot of personal dedication, strong will, persistency, and overall engagement. And I would like to start this panel discussion with Azat. Azat, at the time you were very young. You were part of this structural team at Bureau Happel who was involved in the effective design of the station. If you want to share, I'm sure you have a lot of memories from those days, but...
I certainly do. Can you hear me? Yeah,
yes.
It works, okay. Well, first of all, thank you, Filippo, for offering this opportunity to participate in this panel and to the organizers. As you said, yeah, I was a very young engineer. I was 1.5 years into my career at Bureau Happel. That was my first company that I started working at, after graduation from the university. And I joined the project at the end of concept, early scheme design stage. And I remember, when I first saw of what the concept design is and what task lies ahead for us, as engineers to deliver, I wouldn't exaggerate if I say it was overwhelming. But personally, all I could do is, do my best, give my best to the team, do what I'm good at, and that was the structural analysis and design. And that was literally the next 2.5 years of my life with the design team in our office at Bureau Happel. And when you ask me to think of any stories, any personal stories that I might have about the project, and the first thing that came to my mind, it was one of the last milestones in the detailed design delivery from Bureau Happel. We, as a whole team of structural engineers, it was like 8 of us, stayed up in the office up until 2 a.m., delivering, last checking, drawings, reports. There was a big package, we've been working so hard on it for the past 2 years. And Rusty himself was there at the time. He was the structural lead and our leader of the team. And we basically followed him, and he stayed with us in the office till the end. I think he had to find a room in the hotel to stay in London because he was commuting by train to London.
Commuting from Bath.
Yeah, so he had to find a room in the hotel because basically we had to stay that late, And I remember the last thing I just want to say, after I left the office, I basically walked home from Fitzrovia to southwest London because my head was just, after so much hard work, my head was spinning. I just needed to calm down, but at the same time, kind of to take it in. Yeah. And think, more than 2 years of hard work, and we finally done it. We finally delivered so it's
good,
incredible honor to be part of this. So thank you.
George, what did it represent for you, the responsibility to deliver such a big project? I mean,
well, now looking at the picture, it brings up a lot of memories. Like you said, we spend a lot of nights and days, challenges. When I first saw this project on paper, sitting, pre-meetings, pre-construction meetings, it was a wow factor for me. And I said, wow, this is really challenging. And it was, the most challenging project I've ever had in my career. And, it's a multifaceted challenge. It's the location, it's the design, it's the engineering, it's the interface, it's the integration. All that, it took a lot of us and a lot of the team dedication, a lot of trips to Bergermann, a lot of trips to Zaha Hadid's offices, late nights. It needed a lot of planning ahead of time because there's a lot of engineering into it that wasn't, never constructed before. So we had to make sure that each plan, and like you can see the lattice of the steel and all that, how everything has to be attached to the other element without impacting the vibration on the track. And as you know, a KFD station has 3 tracks coming in. So all that integration and coordination had to happen. And these are long nights, and it was a school by itself in engineering and construction and coordination and integration.
Yes, this is pretty much my same remembering. Mark, we were discussing ahead of this about the collaboration, how important it is for engineers, architects, and specialists to work in collaborative approach.
Yeah, indeed. Can you hear me?
You have to switch it on. Try.
Can you hear me?
Yes.
Yeah. No, indeed. For us, this was very much an achievement, mainly in coordination. The amount of coordination that is ongoing with such a complex shape that you have to achieve, with so many different parties that you have to work with, really was for us the biggest challenge, especially working together with the team from Bax, of course, and with you guys from Zadid. Trying to achieve something unique and really eye-catching. And for me personally, I was maybe in the same position as Azad. I was relatively young when I joined the project, and I spent the next 3 years of my life basically trying to get through it. Honestly, it was very challenging. Premise Lisa did the complete steel structure, freestanding steel structure, and the complete envelope. So there were a lot of multifaceted challenges, but I think the results speak for themselves, and it's really a once-in-a-lifetime project for us.
Thank you very much. So going to Rawan, I have to say that one of the most rewarding aspects of this project has been for me to travel to Riyadh and to see the city and the culture change so radically and so swiftly. And at the time, Rawan, she was very young. She was one of the few women that you would get in contact with at all at the time in Riyadh, right? You were working for Bechtel. Yes.
Yes, correct. I'm a design manager working with Bechtel Corporation. I was basically handling the design management on site with the team. And yes, I started my career as a fresh graduate at that time in 2014. But just to talk about it in summary, when I look back at this project, one of the most defining moments was realizing how deeply connecting my own professional journey had become to the evolution of the station itself. I joined at the early conceptual stages and witnessed the station on site rising layer by layer. As a Saudi architect, it was meaningful to grow alongside a project of this scale and ambition. It wasn't just a job. It became a national story I was living from within, and one that shaped my entire career.
Well, thank you. So one of the most important aspect that of course we faced together with Bureau Apple during the evolution of the design was approaching the structure. And I'm sure, Azat, you have also good stories to tell us about that. Is there anything specifically you would like to bring on?
Well, in terms of structural design, you know, obviously the envelope, the roof is a centerpiece, and that's what gives the station the iconic appearance that you see in the landscape of the city. But the superstructure, what's on the inside of the envelope, is also very, very interesting. And I think we as structural engineers, we developed a design that really follows the architectural vision for the project and for the superstructure. You know, we have a combination of different types of reinforced concrete framing in the basement, and the line 4 and 6 is a ribbed slab. The line 1 is effectively a bridge, if you like, the reinforced concrete bridge that spans across the inclined steel columns. And then the concourse framing with the very slender columns that form the framing support for your sliding doors at the platform. And then we really pushed hard to keep the floor framing of the concourse as well as slim as possible. And all of that, you know, and all the interfaces, all of the coordination and the interfaces that had to be considered in terms of the additional loading requirement for the concrete frame, for the steel frame, all of that had to be taken into account. So effectively, over the course of the design, we progressed with 2 parts of the building that evolved independently up to a certain point. So we had all of the parametric studies on the roof and developing the steel framing that you see there on the image right there, which is the structural steel framing supporting the facade. So all of that was developed parametrically. And in parallel, you had the superstructure that again you see on the next image, which was also, we built bottom up, you know, as a design and the analysis.
On this one, I would like to interrupt you for a second, because the overall architectural concept for the conception of the structure that was supporting the viaduct was to align it with the same direction of the escalators. This site where the station sits was not supposed to host a station in the master plan. At the time, there wasn't provision for that. So it was a very narrow site that was meant to host a normal retail building. And there was no space. You can see how compressed the overall station is. So in order to avoid and to limit as much as we could the interjection of vertical structure inside the station, we decided to align those elements that were supporting the viaducts with the same inclination of the escalator, so that we could couple them and reduce the interference of the structure inside.
I didn't know that.
Yeah, and also we use it to integrate all the MEP and the mechanical ventilation, as we can see in the images.
Yeah, I remember those ducts under the platforms, with the steel framing, and we had a removable floor system for the access and maintenance.
That was an important move that we did at the very beginning of the project. But I mean, we can see here, we can appreciate the complexity of the overall envelope structure, right? So that was also something that at a certain point we realized how significant it was. And there was also another interesting moment when the geometry of those external bays, from being flat, they started being bulged, because we realized that bulging out this geometry would help us to strike a balance in between the size of those lattice that is reinforcing the main pipes, and on the same time supporting the external facade. So this is a very rare case when the overall design geometrical complexity of the envelope has increased during the development of the design for let's say, overall structural performance aspects. Mark, I mean, something which is, and now we get into the realm of magic for architects, because what we design the final form and we design the final geometry of the building. But in fabrication, you have to account for the settlement of the structure, and you have to account for the deformation, thermal deformation, right?
Correct. Yeah. Together with Bergermann at the early stage and with our engineering team, we had a lot of challenges designing the steel structure. As you said, Filippo, the building is designed in a final form. But in order to achieve that, we had to take into account a lot of loads that we will be applying on the steel structure itself, including our own structures, which is the external skin, but also the MEP and other loads. So in the end, we had to pre-camber the complete steel structure of the building to a maximum of 175 millimeters in order to account for the final settlement and deflection of the complete structure. While this was theoretically, of course, something you can engineer, especially with your members, the steel members of a certain size, you have also the issue that the nodes, the connections between those members are going to be welded, and it's very difficult for that to really truly predict where it's going to settle. So when we finally depropped the steel from its props and allowed it to settle in, it was also for us, let's say, a litmus test to see whether our engineering was actually on point. So luckily, in the end, the settlement was in a range where we expected it to be, which was a big moment for us in the construction phase. Not myself, but my colleague Dilip was, I think, with you, George, on site when this happened. And we were all pretty anxious to see how this was settling. But yeah, everything ended well. But beyond that, of course, the theoretical position is something you achieve only when you started loading your materials and your components onto that structure. So we had also a lot of challenges that arose during installation, because we started loading the building from one side, so from the south toward the north. You can see that in some of the pictures. And that we faced a big challenge also to see where the organic shape that, of course, Zahadid is well known for, needs to sit in its final position. So the moment we started installing the ultra-high performance concrete panels, which is the material that you see in the cladding, we were not sure how to achieve the final position, because we were using a total station system to measure where we are in a 3D space, but you only achieve the final geometry when everything's installed. So we had to go off of local coordinates and a very highly adaptable modular system. That you see it a little bit in the pictures, but it was a big challenge for us to
definitely, yes. You can see from the images that this is most probably the first building that at Zahadid we have designed in every single detail, every single shadow gap. It has been designed, so all the position of every single panel outside and inside, it has been perfectly designed from the inception till the completion. Now, another aspect that I would like to discuss with George, it's about the number of complex interfaces that a project like this one brings, right? Because everything is happening on the same time. The whole network of metro is happening. So for us, in terms of architecture, this means that the alignment of the railway is not granted and is not given, and up till the very last moment, it might change of some centimeters. But in terms of delivery and overall responsibility must be...
Yeah. I just want to go back. When you introduced my colleagues, you said they were very young at that time. I think we were very young. You and I were very young at that time also. But yeah, the challenges, like I said, it was I put it's like a maestro conducting with a symphony with 100 of musical instruments. And we felt that way. We in BACS and us, Al-Mabani, were part of BACS, and I was the project director at that time. I felt like I was a maestro conducting, and these instruments were interfaces between KAFD, between RCRC, the client, between the designer, between utilities, between engineering and all the contractors, the details that we had to go to, a lot of meetings back and forth with different stakeholders. We either had our colleagues in FAST, which had line 4 and line 6 that are coming, the alignment, the viaducts coming in and out. So it was at one point when we started, we said there's no way we can meet the schedule and the budget, but as you go along and you pre-plan, and then as you see the skeleton, the steel, each item had to be designed and had the shop drawings, the details, to make sure that everything falls in place. The settlement that Mark talked about, after we're removing the scaffolding or the shoring, it was like you're holding your heart, to make sure that the level of settlement is within the norms, and thank God it's still. And the facade by itself, usually you do a facade, you minimize the orifices, you minimize the type of how many areas that the water can go through. And you see the facade, it's like thousands and thousands of areas that the water can seep through. So all these details were pre-planned and studied to make sure that the design and the architect and the execution falls all in place. So
Yes.
that was the challenge.
Big challenge. Rawan, there was a time when we asked Rawan to join us in London and to be part of the design team for the interiors. What do you remember about that time?
This was part of my development experience with Zaha Hadid Architects when we took the design from the 90% till 100% until the IFC stage in London. Then when I came back here to Riyadh, joining the construction team at that time in 2016 to start the real construction work, starting with the showroom phase and then the real work on site. So working closely with Zaha Hadid Architects, with Filippo and Gianluca Boroni and their team in London, led the design or the architectural vision during the construction. It was very fundamental. My role, yes, was focused on design management, acting as the link between the design team in London and us as the main contractor on site, coordinating with subcontractors and all involved disciplines to ensure the design intent was delivered accurately and consistently, and to satisfy also the expectation and requirement with the customer. What truly defined the project, and I still remember it, and it will remain with me forever, it was the spirit of collaboration we had on site with all teams. We came from different backgrounds, companies, and corners of the world, yet we cooperate and operated as one unified team with one shared goal. That fusion of international expertise, patience, and collective commitment is what transformed this vision into a bold reality. Great projects require time, resilience, and alignment, and this station stands as an evidence of what can be achieved when diverse perspectives move together with purpose.
Well, thank you for these considerations.
And Filippo, too, just to follow up on this, I just came back from Paris. The station got the Versailles prize of the best looking station, best facade station in the world.
Yes.
So RCRC got that present, and this is because of the design and the construction of the station. So it's proud to be part of it and proud to be in Saudi Arabia. It became a landmark in the skyline of Riyadh. So
well, definitely, we've seen that the appreciation of the station as an icon, it has been significant since the beginning. I was impressed to see people queuing outside at the opening, like they were going to a museum, basically. You mentioned on the accomplishments, but prior than that, we also got the LEED Gold certification back in the first months of 2025. But also we hit the target of 3 million passengers, which is significant and unexpected with respect to the provision we had in the beginning. You mentioned this office, and I was hoping to have Ashraf Saleh here together with us today, because he was also. Oh, here you are. I mean, you should be here on site. I mean, you shared the same role, and we owe you really a lot. And as much we do to Gianluca Barone, who I was hoping also to have here. He was the project architect at the time. And so in terms of design, from the engineering point of view, Azat, we have more time. I would like to think a little bit ahead. What do you see coming in the future? We've seen some extraordinary progress in the technology of glass. Now, glass is available in formats that 10 years ago, when we started designing the station, wasn't even thinkable. How do you see the future of the next years in terms of structural design or engineering in general?
Well, there's certainly, the processes that we've used to design this station is something we're using now, and we improving our computational development and our in-house computational workflows for this type of complexities as Bureau Happold. We've been working on that ever since, and that was a really fundamental, I think, project in terms of the jump that we've made from the computational point of view. And and where I think, thinking ahead, I think this station is an example of how the developing countries are looking for iconic projects from world-class architects. And I think we see now the same aspiration and ambition from other countries like Uzbekistan, for example, where they've also, they're aspiring to build something unique that would create an identity for them. And I think it's something, this project is something we can really build on going forward. And yeah.
Mark, what do you think is the future holding in facades design?
Well, I think especially with geometries like this and very complex shapes, that the use of BIM is really evolving in the region. 10 years ago, when we started, we had, of course, aspirations to implement BIM in the way that it's supposed to be done. But I can see really now that the market is really catching up really fast, and especially complex shapes like this with Rhino and Grasshopper. I believe you guys already work a lot with that, but I can see that the facade contractors are also really moving in that direction now, is that trying to automate things, try to allow for early coordination and early involvement. Yeah. And yeah, I think the market is really ready for another iconic building like this here in the Middle East, and I see more and more of these unique challenges popping up across the market. So.
Well, yeah, definitely. It is always been, in a way, an aspect of what we've done at Zaha to push forward the line of the progress, to create an appetite for technology to come after us, and to provide those opportunities that we might have missed at the moment of the design. We were always, in a way, pioneering ahead possibilities that then the markets, the industry, and the technology try to in a way, fulfill afterwards. So, for instance, yes, definitely our same approach to design has been facilitated in the last years because the integration in between platforms like Rhino and Revit has been finally enhanced. At the time, we had to rely on plugins that we have developed internally in the translation of the geometry into Revit. Revit is a great instrument of coordination, BIM in general. The idea of dealing in the same time with the structures and MEP for the coordination together with the overall finite form and extracting information is essential. I can see now great opportunities coming from the implementation of artificial intelligence system. We are already quite ahead in that, certainly for anything that is concerning the initial conception of the project, but more and more about the development, which is yeah, really promising for the next years.
I would just like to highlight the importance of bringing the contractor on board early into design, and I think that was one of the examples on this project as well. I think it's the actual final product I think looks better than the render, and I think it's a big testament to Mark and his team. And I think it's so important with the projects that complex that you have a very good contractor on board as early in the design as possible. And I think it's one of the lessons, and I think something definitely to be considered.
Yes, absolutely. I've always been in a way surprised that the industry of construction wouldn't be as sophisticated as the industry, as like the car and the automotive industry, for instance, right? You would expect that nowadays building of architecture would imply the same sort of industrial refinement in the overall process of construction, which is still lacking. So for this reason, I can see a lot that the future could finally bring into the industry. And conceiving buildings as we would do with the car, electronic elements or gadgets could be a response to that, to make construction simpler, more predictable, easier to plan, and more sustainable in general. Looking at the future, Rawan, you're now working on another project from us, right? This one is for the Minsk Institute in Daraya.
I'm currently working with Zaha as design guardianship for the Minsk Heritage Institute. This is part of the continuity, or developing ourselves through two different buildings. One is so futuristic, and the other one is so Najdi style building.
Yeah, so that's a very interesting learning process for us as well. The idea of challenging the strict codes of Najdi architecture. For us, it's not different from what we would do when we have to deal with a specific brand. We've been designing for Chanel, Louis Vuitton, just to make an example. So it's just about aligning the identity of this client and try to express our own identity in a way that is compatible with that. So it is extremely exciting from our side to move in those restricted margins that a specific code is allowing us. But I think what is very important, just to conclude, is that projects like this one, they have the responsibility of transfer knowledge into local, emerging and developing expertise. And this was the case of Rowan and all the people who, from Saudi origin, have contributed to the project. It is important to see how, as we have witnessed in China, for instance, how the transfer of this knowledge can then flourish into something that is much bigger and much more refined and much more grand to what we could have transferred in the beginning, and how it develops into something which is more important for the progress of the industry. So I would close it here and leave 2 minutes for questions, if you have any. Otherwise, we can most probably go take a break for the lunch. Good. Thank you very much.
Thank you.
Hello, everyone. We're back now, but this is the last session for today, and I think now everyone is full of excitement and enjoyment, hopefully. So let's start. Let's start this day, or this session, sorry. And we will start it with Austen from Hawkins and Associates. So please join me to welcome him on the stage.
Okay, so I'm Austen. I'm a senior associate with Hawkins. And firstly, I'd like to thank Zak World of Façades for inviting me to present today. Okay, so first I'm going to talk a bit about who Hawkins are. Then I'm going to go through some environmental issues, fire safety defects, and then I'm going to close on a case study with the Museum of the Future. So, Hawkins, we were established in Cambridge in 1980. We originally started off as fire investigators. We specialise in root cause analysis, expert witness services and engineering consultancy for the insurance, legal and risk management and commercial sectors. We are solely employee-owned company, and we have about 150 experts across the globe. And we deal with a range of expertise, fires I've mentioned before, floods, marine, power and energy, and of course built environment, which is why I'm here today talking to you. And we can provide a wide range level of investigations from free consultations, desktop studies, all the way through to a full investigation on site. Part of the Hawkins Group now, this last year we've just bought 2 companies. So we have ALA, who are cost consultants. They deal mainly with construction clients. And then we have M&B. They work with heritage buildings and on the employees' side. So I'm going to talk about sustainability, but the following issues are only going to have a light touch. And if we can't get these right, then we have no hope in meeting any of the targets that might be set to reduce energy consumption in buildings. So in most European countries, condensation can occur internally. In this part of the world, it's the opposite. So we generally have condensation occurring on external surfaces. However, we do have the issue where that condensation can occur internally. So this first issue, you might be able to work out from the photograph what's caused this. So this is the head of a door frame to a balcony. and you can obviously see there's quite a lot of condensation. So this is the shop drawing for that door. You might be able to see we've got 2 thermal breaks within that frame. One of them is breached. The red square is where the photo is. So that's the top of the frame for the actual opening of the door. There's no consideration of drainage. And also what we have obviously is external hot air has met with the frame that's been cooled internally, and that's caused the condensation. So we try to keep heat out in this region. And here's just a typical photograph of a villa being constructed. I don't know how well you can see the end walls, if this is going to work. So here you can see the thermally insulated block. Obviously it's not been installed correctly, so that leads to thermal bridging. If we put that thermal block and an external finish and an internal finish into the U-value calculator that Dubai asks you to use, you will get about 0.5 U-value and a requirement of 0.57. If you put that same build-up into a more sophisticated piece of software, you're going to end up with a U-value that doesn't comply with Dubai regulations based on the fact that that software is going to take into account the mortar joints between the blockwork. And then the final environmental issue, it's already been spoken about today, is leaky facades. And I'm talking about air infiltration into buildings. And obviously once this happens, we can get moisture inside the building, which can lead to mold growth. And can also cause damage within the wall build-up itself, which you're not going to see until things get really bad. So in addition to leaky facades on their own, we also have the impact that HVAC can make. So let's take a hotel, for example, and say the return air from the guest rooms causes a negative pressure. That's going to pull hot air into the building and cause more issues. I've got one particular case, which I can't disclose, where every single guest room within a hotel had suffered from infiltration and mold growth. They then had to close one by one every single room, undertake remedial works, and then what they found was after the first room had been remediated, they went back and the mold had come back. So they hadn't solved what the root cause was. So a solution for all these issues is what's simply called a pen test. And you can do that for your rainwater protection layer, your insulation layer, or your air barrier layer. So basically, what you end up doing, if I can work this, is you trace the element with your pen, and anywhere that you end up having to lift your pen off the paper, you have a problem and you need to look at that in greater detail. So fire safety defects. This building's been shown before today. And those who don't know it, this is the 24-story Grenfell Tower. So just before 1 o'clock in the morning, a fire was reported in flat 16 on the 4th floor of the tower. Less than 10 minutes later, that fire had broken out through the window. Then less than half an hour after the original fire, it had reached the roof and had started to spread horizontally. So what were the main causes? The aluminium composite panels on the outside of the building and defects in the design with the installation of the passive fire protection system. Basically, a lack of fire barriers. So let's say we've got an apartment building, which generally should have a 1-hour fire protection to the walls. And a fire within should be contained within sufficient time for the occupants to escape or for civil defence to arrive and put out the fire. But what happens if the fire breaches the window? So generally, flames will extend to about 2 meters above the height of the window and will gradually break back into the building and climb up the building. But what happens if there's an unprotected cavity? The flame will extend between 5 to 10 times its original length, regardless of the material used for cladding. So from a designer's perspective, what we should be doing to overcome that is all your compartmentation lines and all your cavity barriers should be shown on the drawing so the contractor knows where they need to be installed. And I'd also suggest a similar pen test to the one I showed before, only this time, if you don't have to take your pen off the paper, then you have a problem. So the next topic is the museum in the future and its facade. So the facade is a composite of stainless steel and glass reinforced fibre panels. There's about 1,024 individual panels. Each require a bespoke mould to fabricate them. The largest panel length is 18 meters, and each panel ended up costing around 250,000 dirhams, and that's why I got involved in this project. So I'm going to be talking about a DAFC court case, and I can do that because this is also on YouTube. So if you go onto YouTube and go onto the DFC courts page and type in that case number, you will be able to watch the hearing. So why did it end up in court? And what lessons can we learn by those specifying facades? So this was the tender specification. It was a performance specification, and the contractor was to be responsible for any technical aspects. And it also stated that the tender package reflected the detailed design, and the specification outlined the technical performance requirements. So those requirements within the specification included, in relationship to the panel sizes, a suggested module size of 2.5 by 4.5 or 9 meters by 3 meters, with a suggested vertical span of either 4.5 meters or 9 meters to align with the diagrid structure of the building, which was every 4.5. But it said the module size was to be to the preferred contractor's design. So basically, it was up to the contractor how he wanted to do that module size. So the tenderer's response was that he was going to provide a composite facade and that the stainless steel panels would be mechanically fixed to the glass fibre panels, and the facade panel size was going to be 9 meters by 2 meters, and it was going to have a double curvature to those panels to achieve the form of the museum. As part of his tender proposal, he produced a mock-up. Part of that mock-up showed horizontal lines between the stainless steel sheets, and also, you probably can't see clearly on that image, but maybe on this image you can see the exposed rivets where he'd mechanically fixed the stainless steel to the panels. Post-contract award, he was issued the AFC drawings. None of them had been updated to reflect the facade contractor's proposal. In fact, the facade contractor was told to ignore everything in his tender and to use the AFC set. So what happened next? The design team requested a series of options for the facade to be explored. The exposed rivets to fix the stainless steel sheets were rejected, as were the horizontal joints between the stainless steel sheets on a single panel. So, the design options delay production of the shop drawings and production of the panels. The rejection of the rivets required studs to be welded to the rear of the stainless steel panels and corresponding holes drilled into the panels. And then a hexagon pattern was a laser cut into the stainless steel sheets, and then a zigzag cut joint at the edges introduced to hide the joint lines between the stainless steel sheets, which you can see on that image there. So how did it all happen? The facade was for the contractor to complete the technical design, and the performance specification and design intent lacked sufficient constraints to maintain the architect's vision without the need for design changes during the contract works. The specification was not sufficiently detailed to prohibit the use of visible fixings, and wording such as secret and invisible fixings should have been used. Instead, the specification just stated the stainless steel was to be bonded to the FRP panels. The horizontal joints between the stainless steel sheets, again, the specification was not sufficiently detailed to prescribe the location of the joints nor their pattern. We're still waiting on a judgment for this, so not sure at this time who ends up winning, the main contractor or the facade contractor. So that's my details. If you have any questions, feel free to contact me at any time. Thank you.
Hey, thank you so much, Austen. That was really amazing. And now please join me to welcome Valeriya from Dow.
Good day, everyone. I think many of you a little bit surprised. You've seen a different person on the schedule. We had a last-minute change, so thank you, Zak team, for accommodating us and changing the presentation and title and letting me to present. So I'm Valeriya Chernikova, and I'm EMEA Marketing Manager for Building and Infrastructure. I've been with Dow 7 years and in Kingdom for 12 years. So I'm very excited to talk to you about the role of silicons and enabling sustainable design in the buildings. So I urge you and ask you to please think how silicons can enable, sustainability in your project. So what is Dow? Dow is an American chemical company, of which very big volumes and reach, right? So we're at 43 billion net sales and around 36,000 employees spending over 30 countries. And in Dow, we like to ask the right questions to provide the solutions which fits for purpose, right? So we're doing it through fostering collaboration with our customers or stakeholders. Right? So engage with us if you have some, interesting task which could be solved with material science. Dow is a very big company. They have different businesses, and the business which represented by the team here, we have the desk, is a consumer solution. And consumer solution is a leading global silicon player and industry leader for over 80 years. What we provide, we have the unmatched portfolio of the performance-enhancing silicons and specialty materials, which spans to very different applications. that doesn't want to show, but like mobility, consumers, electronics, personal care, and of course, building and infrastructure. So today we're talking about the buildings. I'm sure this information is not new for this audience, but if we're thinking on how built environment contribute to CO2 emissions, we know that 34% of global CO2 emissions come from the buildings, and 13% of it coming from the embodied carbon, which is on the construction phase, and other 21 is on the operational side. Of course, we want to reduce both. And luckily, fortunately, there is a push from the industry to reduce for this net zero emissions and to reduce carbon emissions. And this is driven by global government targets, like 2060 in Saudi Arabia to be net zero, through the green building certification. You have LEED, you have Mastodam. There's different specification too. And again, I want to highlight, we know how important it for us to engage with architects, with building owners, with the property developers to advance this and implement it in Kingdom or in the world. So there's 7 principles of sustainable construction. So we start with durability, energy efficiency, waste reduction, indoor air quality, water conservation, and so sustainable building materials and sustainable design. In this talk, I will talk about design consideration and the sustainable building materials by introducing our carbon neutral silicons for facades. If we're talking about sustainable design, right, we're talking about material efficiency. Right? We want to build with the right materials. And there's several things we need to take into consideration. We want to reduce the material use. We want to reuse as much as we can. We want to recycle if we cannot reuse. And of course, that comes to disposal. So let's start with reducing. So how do we go to reducing? So silicons can reduce the energy efficiency of the building and increase the material efficiency. Why so? So silicon sealants are they're weatherproof. We have excellent climatic resistance, have really good movement capability and adhesion. What it does, it creates airtightness. Airtightness contributes to energy efficiency of the building. The second point on the material efficiency, we want to use it for a long time. We want to sit it on the building for a long time. And this comes to durability. Durability improves, like if you use in silicons, because it's inorganic materials, it's highly UV stable, it's basically indestructible. So it's improved carbon balance over facade lifetime more than 20 times. How do we know that and how we can claim that? So Dow actually pioneered the four-sided structural silicon glazing in 1971. That gives us confidence to claim the proven performance over 50 years. And it's also evident by construction selecting us to specify Dow seal product in 18 of the 20 world tallest towers, including Mecca Clock Tower, as you can see in the slide. And right now there's a construction of Jeddah Tower in Jeddah, which supposed to be higher than Burj Khalifa. So you would think silicon is a small element of facades, right? But it still can contribute quite a lot. And I want you to compare 2 systems. One is structural glazed system, where the silicon bond the glass. And another one is a captive system, which is the glass is held by the aluminum and the gaskets. And let's look at the 2 components of it, right? There's operational carbon, energy efficiency, and this embodied carbon, which is material efficiency. Let's look comparing the energy efficiency. Let's consider this captive system and the structurally glazed system. We take this case study, and in the scope of this case study, we take this representative facade, standardized, unitized facade system, We want to use similar frame thermal performance, identical glass build-up, and same loading condition and same structural performance. What we're comparing is U value, right? Once you have it in the system, U value is your thermal transmittance. You want it as low as possible to have this energy efficiency on the building. And by compiling the simple, analysis, we can say that this structural glaze system can reduce your, energy consumption. They can improve the thermal factor by 10-25%. This is on the embodied carbon, right? You have the better U value. On the material efficiency, right? Imagine, just if you're using structurally glazed system, you will reduce the aluminum use, right? So you can reduce aluminum weight, aluminum reduction up to 15%. There is no need for replacements of the gaskets during the use. There's also reduction of the metal reinforcement in the windows through some bonding. And what it does compoundly, it reduces the size of the profiles, right, specified in the facade area. So it's a composite effect. And to say more, we're not only there to supply you sealant. We have the technical team and the tool where you can submit your drawing and we can analyze the design and provide you corrected bite size for your sealant, right? So that's available and online. It's called Cool Construction Online System. So please check that out. And so this was the case of reducing, right? Reducing the material. If we cannot reduce, and can we reuse, right? There's a lot of we don't want to just build, we want to also reuse materials. So this is a case study, how silicons enable the glass reuse in the certain building. So this case study is around refurbishment of the vocational college in Zurich. What happened in 2021, the city of Zurich wanted to refurbish this building because, the energy performance was not great and acoustic performance is not good because it was built in 70s, never been touched. And the goal of this building was to really reuse as much material as possible. So this beautiful red glass, the covered with animal, they wanted to reuse it. But they checked it and structurally wasn't sound, right? It needed sort of reinforcements. That's where we connected and tried to find the right solution. We tested several, of our sealants and come up with a solution where this perforated metal sheet was glued to the glass with the silicon sealant, which we choose through our portfolio, and this is the right one. We tested it in the lab. We tested it in the, for impact test, and it was performing well. So this project have been completed in 2024. So if you're in Zurich, you can see it. And there's something I want to ask you. If you have refurbishment project and you're starting something and there's a need for some, technical solutions, chemical solutions, we are there to have this conversation and try to find together the right solution, right? That's, for us, it's very interesting to engage in this sort of innovation too. So this is on reuse, how silicons enable the reuse. If we cannot reuse, can we recycle? Again, silicon is a small part of the facade system. No one really looking at the silicons as a recycling source, but most people really want to recycle like the glass or aluminum. And there's misconception on the industry that silicon's hard to debond. So I'm here to tell you it's not very hard, and it's something we study. And we do different, we're analyzing different techniques and how you can use it with this sort of cutter, like oscillating cutter or hot blade cutter, to have a clear cut and debond it back together. So it is possible, it enables recyclability. We also the chemical company, right? As a chemical company, who especially producing silicons, and we have silicon metal side, it's very energy intensive to produce silicons. We want that material back to reuse them, to recycle them. But there is no really infrastructure right now for collecting silicons as a waste. There is no, it's not the ecosystem for this is not developed. So we're always looking on the ways to identify and quantify the sources. So we are closely monitoring the advancement in the field of debonding of the glass and metal. And here's the IG2 pieces machine, which was developed by Hegla and AGC. So for us, of course, they want to preserve glass. For us, can it be a source for silicons to later for us to convert and use in our new formulations? We're very good in formulating the sealants, right? So what about converting the stage? Converting stage, how we actually recycle. We also do progressing quite well there. We have this great collaboration partnership with Circosteel LLC in North America. We have also another partnership in India where we start recycling our own post-production waste and the industrial waste from our customers. But again, we need more, right? It's a volume game. So to get more materials back in, we want this ecosystem to be well established. So this is on the recycling part. Let me come back in the last bit of my presentation. I want to introduce you the carbon neutral silicon sealants available for Dow. We were the first to introduce it, and this system is available worldwide and third-party qualified, certified. So how we can do it? As I said, we're a backward integrated company. We produce silicon metal, we produce the polymer, we formulate our own sealants. So we have this value chain of production. And if you're looking on the footprint of the silicon sealant, the biggest contributor of the emissions, right, like of how heavy it is on the environment, is the silicon metal production. We produce silicon in our plant in Brazil, and we able to reduce that by using hydropower and other renewable elements. We also use natural resources and it's third-party certified and audited, like quartz, wood chips, charcoal. And this significantly reduces the carbon. But we can take it further, and we can use all our own carbon insets. You would think, what is this? That was a chemical company. We actually own the eucalyptus plantation in Brazil. Eucalyptus is growing very fast and gives very good carbon insets. And it's third-party verified, and we can, provide this service. Of course, this external certification costs some money, so this is our premium offering, which is available by the project. Even if you completed the project with Dow seal system, with one of this element, you can get some carbon credits to your project. So please connect if you're looking for this. Just to give you a little bit of quantification, right? Like we're also science-based company, we like numbers. And if we're looking at the carbon footprint for standard silicon sealant is around 8 to 12 kg of CO2 equivalent per kg of the sealant. If you move it to, understand that how much it is in facades, it's around 20 kilograms per square meter facades. If you consider the building with 30 square meter facade, basement, it will end up being around 600 tons of CO2 equivalent savings. So I urge you to consider this, like to have the simple calculation with your project and reach out if there's a need. On this, I'll finish my presentation and thank you so much for your attention.
Thank you so much. That was really amazing. And now, the last speaker, please join me to welcome Mr. Magdy from ALWAN.
Assalamu alaikum. Good afternoon. First of all, thank you for your time to attend our topic about powder coating. I think I already prepared this presentation actually. According to what I already collect, a lot of questions about powder coating. So today I will not talk about what's ALWAN powder coating, because I see some of our partner, our customers here. It's our pleasure. But today I promise in next 10 minutes, I will just only discuss and take a journey with powder coating, starting from what is powder, till we will go the specification for architectural segment. This is my goal of today, inshallah. So first of all, that's why my presentation, I call it, what is powder coating? Of course, I know some of us, they know some information about powder coating, but today, as I told you, I will arrange and go step by step to give you clear picture about powder coating in this 10 minutes, inshallah. So first of all, why we didn't say powder paint, not powder coating? First of all, the first point in the coating, or if I would like to go for the definition of coating, the first aim for coating is a protection. Then we can go for the second one, the decoration, the color, what you'd like to select. That's why if you'd like to see in powder coating, we say powder coating. In another industry, we call it protective coating, marine coating. But in paint, when I say paint, the first aim for this one, it is a decoration or is to select the color. But when I would like to say coat, the first point, I would like to say this is for protection. Then the second point, I will go for color. That's why I would like to make a comparison between paint and coat as a verb. Why powder coating? I will not make a marketing about powder coating, or I will use my selling skills to market about powder coating. It is nothing new. But the people, why they already go from liquid paints to powder coating? First of all, there is no VOC, or as we call it, volatile organic compound. Zero VOC, there is no in our earth is zero. To be honest, we can say 0.00 something like this. So it is no comparison between liquid paint and powder coating in this point as a volatile organic compound. Second point, easy for cleaning. Let me make a small example. It's looks like a dust. Easy to clean it, even if we put it in our booth or the production line. No solvent, no need to make, during our production, I need to make any solvent to try to dilute this powder coating. Totally, there is no any solution in this powder coating. Another point, if I would like to talk about the human, there's low risk on the people on this one, because as I told you, first of all, there is no solvent on this powder. Another one, easy to apply. If you can see here, we just only need electrostatic gun or pulse, and you can control it by unit that you can, for example, from the beginning, from 8 o'clock till 4 o'clock for the people, they will manage the all performance for this powder coating. The performance and another point, it's too much. That's why the people, maybe some people, they ignore what I already say on the beginning, but these 2 points, the performance and the economic benefit, that's why the people believe on powder coating more than liquid. I don't like make a comparison between powder coating or liquid paints. Just I would like to highlight why the people shift from paints to powder coating in 90s, 50s or something like this. The economic benefit, the first point, you can use the recycle for powder coating. This is the first point. And for example, if I already sell 20 kg, our carton, it's already 20 kg, you can use, if you have the full production line, you can use 95% from this powder. Plus the performance, when I would like to see the performance, I would like to highlight about the protection. The protection benefit for this, as I told you, it's already not less than 60 micron. At the powder coating, we talk about 60 to 80 micron. This is the average of this one. Of course, regarding the specs, we can increase or reduce regarding the specs. But 60 micron, comparing with 30 micron, something like this in this time. So of course, the protection here is higher. Powder coating formulation and manufacturer, I will go for this headache for all of you gentlemen. I just would like to focus, this is the formulation, just only start from the backbone of our industry. We call it resin, or in Arabic we call it enrating, باللغة العربية. But I would like to, as we already get it from outside, we call it resin. We have a lot of type of resin. Curing agent, we have additives. And additives, when I say additives, just only, we mean from 1 to 3% only from our formulation, we add this one. Plus, we have the tint pigment. The tint pigment, which is what we really need. I need yellow color, black, yellow, white, whatever. And the last point, it's something we call it filler or extender. About the manufacturing, how can I produce the powder coating? I just put small layout about the factory, starting from here. No need for this. Starting from here, we already put all these ingredients in this pen. After this one, we will go for something we call it pre-mixing for all these components. And then in any polymerization industry, we must have this, we call it the extrusion. That will make mixing for all these ingredients by heat till we will get sudden cooling here, till we get small chips. In this case, I already make sure all ingredients and powder, it's already become homogeneity. After this one, I will take these small chips and go for grinding machine. This way can go at the end to our box. This is the normal processing for powder coating manufacturing. Because actually, I added this one because some people, sometimes they say, I check this box, I found some defects, but the other box it is not. Of course, this is a lot of troubleshooting what we face it on the application with the applicator. Another slide, I would like to talk about powder coating market. Powder coating market is, I know most of us here, we talk about the architectural segment. But actually, I would like to highlight about powder coating market, which is already all this one in our life. We will discover now it's already in all home appliances, what we already have it in our homes, it's already powder coating. Even your gas cylinder, what we have it here in Saudi Arabia with orange, it's already powder coating. Architectural, of course. All this agriculture, construction, and earth moving equipment, all this one, it's already also by powder coating. All this, what we call it in the automotive, a lot of parts in our cars, it's already coated by powder coating. Of course, the specification for each industry is different. I'd like to just highlight about the markets for powder coating. The functional, the pipeline for oil and gas industry, also, they already using the powder coating. Furniture, a lot of segment in furniture, they already using also the powder coating. For example, at least, if you would like to go for this seat in our cars, the steel structure for this seat, it's already coated by powder coating. General industry, you can imagine anything, it's already coated by powder coating. I don't know if we still have now this satellite dish in our homes or no, but this is already coated by powder coating. If you go for pharmacy, you'll find these shelves. It's already by powder coating, transformer, electric control panel, this lighting pole, all this one, it's already using powder coating. This segment, I think it is not here in our region, or we can say it's not in Middle East for this IT or consumer electronic like gambling or this ATM machine or something like this. It's already also coating by powder. Here I just would like to highlight, even I pass how can we produce powder coating actually, but I already would like to focus because a lot of maybe I would like to make sure to all of us we know how can we apply the powder coating, because actually today I would like to double check about 3 triple C letter. I would like to clarify at least and confirm and correct some misconception for some of us. That's why if I would like to, this is powder coating manufacture, application. Powder coating, it's already started. To put it inside the cabinet, this is the aluminum profile. This is the loading area. After pre-treatment for the aluminum profile, they will go to the booth, and you have here the report, which, as I told you, we have here a specific parameter. All day you can control it without any changes about the film thickness, about the KV, about the microampere, everything is already controlled. After this one, it can go for the second stage, and this is the technology actually for booth. What I already informed you on the beginning about the recycle, I can use the recycle. Here the recycle, by centrifugal theory, I can reclaim the powder and returning again to the booth or the feeder, and the fine powder, it will collect it here. In this stage, powder coating, it's already go from the booth and go for the oven or curing oven. Regarding to the manufacturer specification, the applicator, he should follow our instruction. For example, if he already take standard or super durable, for example, I will give him a recommendation. I need 10 minutes for 200 Celsius degree. So he must make or adapt his oven to get this temperature on the metal, not air temperature. I focus on the metal temperature. Now, with the journey, as I told you, the journey with powder coating, now I started what is the powder and the application, and now I'd like to start with the substrate. Powder coating, all of us, of course, here we know it's already with aluminum plus steel, but for your information also, the powder coating can make coating for wood, or MDF as we call it. Wood, it can be applied by powder coating, but to be honest, it is not this application, it's not available here in not only in Saudi Arabia, but I talk about Middle East. It is not also available. But I just like to highlight usually aluminum with all types of aluminum and alloys and steel. Even when I talk about steel, I talk about stainless steel, galvanized, black steel, whatever. All these types. But also everything depends on the specs and what's our recommendation to make this one. For example, if you would like to go for C4 or C5 areas, of course you have a different specification. For me, actually, we have a lot of defects. I will not discuss about this troubleshooting or defects about powder coating. I just would like to highlight about two things or two defects. All of us, even if we already have experience in industry or not, but all of us, we can note it. First of all, if you have color retention or gloss, color retention or gloss retention, or we can say even this color deviation or gloss deviation. Some of us, we cannot, even if I'm not experienced in our markets or our industry, I can see, yes, this color lighter than this, or this color darker than this. That's why I highlight this is one of the main. And the second one, it's corrosion. And this is a bad thing, actually, I don't like to reach about this one. Even aluminum corrosion, or to be more specific, we call it aluminum oxidation, or even for ferrous, that to be stable, he must make some rust to be stable and to avoid this oxidation reaction. So this is the most major, or for me, as a sales and technical manager for powder coating manufacturer, this is the most two topics, actually, every time I'd like to clarify about this. Here, I just would like to highlight about some example about color or corrosion or whatever, before and after. I don't know if you can see the resolution here. It can give you what it can be before and after. It's clear? This is before, same color, and what happened after this one. For many reasons. Today I will not discuss about the reasons, but today I would like to give you a highlight about some example. Then we can go and make the root cause about this one. But actually, this is before and this is after, and same color, same product, so it's a question mark. This one also, same color, but this is before and this is after. A lot of things. Maybe we have here some corrosion. Maybe he already select not good powder, or it is not comply with his requirements. Maybe the cleaning. And this is very important for the architect here or the consultant. It is very important. Once you already finish the project, you must ask about the process for cleaning or maintenance for powder coating. Because after this one, even if I will give warranty for the project, but I will ask you, did you already follow the maintenance and repairing process? He doesn't know about this one. So that's why even for this one, you must ask about this or include it in your guideline. Also, same example, the same concept. Now maybe I will go for the aluminium oxidation or corrosion from actual samples. This is a grade of corrosion or oxidation for aluminium, but you can see, of course, no one would like to see the project reach to this area or this level. The corrosion started from here. Maybe he has problem in the pre-treatment or during the fabrication. He has problem. Also here, the same, but he has problem. This is good, but maybe he didn't, because he didn't make pre-treatment here. He already lose the adhesion and the start corrosion. Steel. If I'd like to go for steel, here also the corrosion depends on the project. Sometimes we face here in C3 area or the mid of Saudi Arabia, like Riyadh, you face corrosion like this. For this project, you have here the fence, the column here, it's already from black steel. This is galvanized, but because of maybe small screw, it already started the oxidation cycle or galvanic cell to start the oxidation. That's why I already highlight about some real example about this one. Now, to go for architectural, I would like to highlight about what we have here. The most important specification, what we already follow in our powder coating industry, we call it the QualiCoat certificate. The QualiCoat is already an institute which they already make classes about powder coating. Mainly we have 3 classes, class 3 and class 2 and class 1. Based on your specification, you should select this one. For example, 1 year exposure, it's already Florida test, which when you already, with this category, you can go for 10 years warranty for this powder. Here, 3 years in a Florida test, you can go 20 years warranty. The last one, we call it the hyper durable. Here we call it standard durable, super durable, and hyper durable. By the way, this is a scientific name. I didn't say my commercial name. All these classes based on your project and based on your lifetime for each project, you can select this one. This is QualiCoat from Europe, but here we call it here AMA or American Architectural Manufacturer Association. Also, they make the same concept but different codes. Yani for example, class 3 category, it is AMA 2605, 2604, 2603. Almost they are the same. Very, very limited or a little difference between this AMA or QualiCoat. At the end, I would like to highlight about what we already talked in this last 10 minutes. What is the powder coating? Why powder coating? Formulation and manufacturing for powder coating. The markets for powder coating. How can we apply the powder? And then I'd like to highlight about the substrates, aluminium, steel, and wood, defects, and architecture. At the end, I hope if I already add small value for you. I didn't think about our company. By the way, it's ALWAN Powder Coating, the first Saudi company here in Saudi Arabia from 1993. At the end, I hope if you have any question, of course, pleasure to get Any question after this section? Or if you would like to contact for me for any technical, before any sales, we're already available. Thank you for your time, gentlemen.
Thank you so much. So now we're heading the last thing, which is the panel discussion with amazing speakers. We're going to talk about some very important topic. So let's just set up the place and I will welcome my guests. Thank you. Okay, so first speaker or panelist, please join me to welcome Mr. Marwan Abbas from Khatib al-Alami. And the second panelist will be Mr. Walid al-Sayyid, Design and Studio Director from ALWAN. Sorry. And the third panelist will be Mr. Bassem Hilal, Project Director in Premium for Aluminum and Glazing Systems. Also, please join me to welcome Mr. Samer Mohamed, Finishing Materials Development Head from Abdul Mohsen Al-Diab and Partners. And last but not least, please join me to welcome Mr. Ja'far Abdul Rab, Façade Manager in Ahmadiyya Contracting. Ahmadiyya? Please excuse me, a lot of names today. So, how are you guys? How are you doing? I hope you had a great day today. As you saw, we have a packed lineup, but I hope you enjoyed it. So today, as you know, we have kind of a dense topic, but it's super important. And I'm looking, and I'm sure the audience as well, looking to hear from all of you guys and from your experience and expertise in that topic. The topic will be about the importance of the early engagement of contractor and early stage of design. And we kind of will make it structured in a way to address the issue by highlighting the problems or the challenges or the common issues that are happening in that sense, and then we kind of move into different topics. So I will start with Mr. Marwan by asking a question. A lot of people maybe don't know what kind of issues that might happen, or challenges, if we call it challenges, that might happen if we didn't engage the contractor in early stages of design.
Yeah. Well, marhaba Faisal, how are you? Actually, the early engagement of the facade contractor is really has more benefits than the challenges that it puts forward. I believe that the challenges come from having two different types of contracts. One of them is design and build, and the other is design and procure and then build. The marrying both types of contracts always creates such problems. You need the facade contractor to give you his expertise, his specialty. However, you need also to procure in the classical way, which is the procurement laws are built upon, and the contracting atmosphere is always built upon. Engaging the facade contractor early on gives benefits to first of all to the contractor himself, to the client, and to the whole project as a whole. The contract becomes in that way. If he is engaged early, you will know early on what is the design, what are the design decisions that you need to make, such as the anchoring, how you are going to anchor the facade to the building, what is the performance that you want to get from the building, what is the the shading qualities, all the expertise, all this expertise is early on injected in the design stage. So when you reach to the execution stage, post-contract, it becomes very, very easy for the contractor to evade, and the client to evade delays related to procurement of a long lead item, changes coming, impacting the procurement because of some changes in the design. The performance didn't work out, the anchorage is not working, some certain structural requirements needed. So it becomes much easier for the contract to go smoothly without being impacted with delays. Definitely, client will have, if he engages the facade contractor early on, definitely he will have a better business case. He is reducing time, he's reducing cost, reducing long lead, estimation of long lead items that become delayed and delay the project, the handover of the project, with all the impact that this has on his feasibility. So yes, I believe it's one of the. Of course, there are challenges related to this, and I believe we are all facing such challenges, witnessing such challenges. But definitely, the benefits are much more outweigh the challenges.
Great. And talking about the most important thing, I think, in any project, which is the money, simply. What is the, and this question goes like to anyone, I would say, maybe let's start with Mohamed Bassam. What is the kind of, I would say, the economic value of early engagement of facade contractor in the early stages? Yeah, you just turn it on.
Yeah, it's working.
Okay.
No.
No.
Excuse me. Now, if you want to look for the return of investment on early involvement of a facade contractor, you can take it in different ways. Considering the short-term return on investment and the long-term. On the short term, it means that on pre-design, we can customize the design, go for testing and retesting for any system that can be customized, to go for a local production, let's say, and early reservation for raw material, except, for example, glass or whatever of even our colleagues that we have show us earlier. This is for the short term. This involvement also give us the avoidance of many risks in terms of shipping factors, maybe, and accessibility and earth-moving equipment that can be used during the project. On long-term project, and I guess all my colleagues here that have witnessed this many times, is the maintenance cost. Okay, so I'll give you a small example for this issue. Like sometimes we have witnessed that a huge glass panel and some isolated villa somewhere in the mountain that costs you maybe 5,000 to 10,000 riyals to change it if it's broke during the execution time. But for maintenance purpose, if anything happened, let's say for thermal fracture or whatever the reason that you need to go for maintenance, sometimes the operation can cost you up to 50,000 just to change one glass panel. And this can be reduced or maybe even eliminated by early involving the facade contractor that can see the things from ground level, from operational level, from execution level, and can accommodate any type of the equipment, manpower, expertise of the manpower needed, and adaptability of any of the suppliers that are available locally or regionally. So I guess, as Mr. Marwan also said, that the benefits of engaging the early facade contractors go much more than not involving it. And the return of investment and the return for the cost is much more safe. We can save much more than not involving it. And maybe you heard this one before. I guess in order to save money, you have sometimes to pay money to save it in a later stage.
Great. And speaking about the same topic, Mr. Ja'far, do you think the clients will value that? Will value the economic value of early engagement of facade contractor?
Yeah, for sure. Okay, in a small words, okay, you need to pay more to save more. Start early, okay, may it will have many challenges, but if it work in the correct way, for sure the benefits will come for the project benefit that's reflected to the client, okay? Early engagement, it need actually 3 challenges to be reflected in the correct way. First one is the timing, second is the access, and third is the cooperation. The timing, early engagement, it need to happen before the decision have been frozen, so the facade specialists have the opportunity to improve and to be adding value for the project benefit. The second point is the access. If you even engage the facade specialist on early stages without giving the access on the decision loop, this means it's politically more than a productively point. And the third point, I think, is the cooperation, okay? The stakeholders, the clients need to be involving the facade specialist in early stage, not to resist the change and freeze the decision. They need to cooperate with him actual, so his improvement will be adding value for the whole project. The late stage actual, as a result for late stage, always we are facing delays in the project. We are facing disputes, design disputes, redesign, hundreds of RFIs, hundreds of RFCs, which all will lead in finally to lose the time and cost certainty, to have a lot of variations, a lot of claim. So early engagement will make the full procedure smoother and cleaner, and it will be more predictable for the delivery of the project in case the three cruise domain have been available: the time, the access, and the cooperation.
Great. Mr. Walid, on the same topic, since it's quite important, which is economic value of early engagement. From your perspective, because I know it's kind of different from you coming from a Liwan, and it's kind of different with other perspectives. So I want you to kind of share something about that.
Let me start. Actually, the journey is starting from the developer, the owner himself. When he gets smart enough to know actually what he wants to design. So from the first step, he should define the design objective that he will looking for, the segment that he will gonna design for. This will help more to understand the specification and the type of facade he wanted to design from the beginning. So when we got to design a building, or he wanted to develop a building, that iconic building, it should be treated different than we are going to develop a residential building, administration building. Each type of building, it needs a different approach. When we talk about iconic towers like Burj Khalifa, we will not discuss the cost. We're not focused on the cost in this situation. Okay, we're looking for the iconic architecture element. So definitely the ROI or the return on investment will come from a different application, and different development could be happened around the iconic building. When we are going to develop a residential building, we have to think about the segment of the client. If it's for a middle class, or it is economical buildings, or it is elite segment. So in this case, we have to define the specs of the facade, which should respond to the needs of those clients. Actually, we are, as a developer, we have an experience in this situation. In our project, we used to develop a mixed-use project. So we have this a recipe of functions: the administration buildings, the hospitality, the residential buildings. From the beginning, we defined the segment, and we get all the expertise, the facade contractors, one of them, we get it involved in the early stages of the design in order to define the proper system that achieving and responding to the needs of our segments. What's happening when we shift to the execution on site? Actually, once we had signed the agreements with the contractor, we have no delay on time. The contractor is on time and on schedule. We did not exceed the budget. Actually, he didn't lose time in the material approval, since the materials and all the specs are very clear and defined from the beginning. So the project moved very smooth on time.
Great. Amazing. So I think now let's move to something different. We've seen, all of us, like the booming that's happening now. A lot of project, a lot of construction happening. And that question goes to you, Mohamed Sommer. Do you think that will affect the supply chain when it comes to availability of some materials and so on? So I want just to hear from you about that.
Hello, everybody. I'm very happy to be with you today. Thank you, Faisal, for your question. Regarding your question, we try to, we have a challenge for the materials, really, in this, for the integration. If we're talking about the supply chain, it's very difficult issues to do that. So we have to go with early stage to try to check about the materials which take time, the long lead time. Maybe we have to order before by the suppliers, and I think also the integration between the designers and the contractors with also the suppliers, also the fabricator, it's very important, so that we have to check always about the integration and experience for the lessons which we learned before from the previous projects to avoid any delays. From my side, there is some materials like the alternative material of the traditional one. We can get some difficult to order, like maybe as for example, UHPC. It's a very huge material and it's difficult to arrange as a big quantity for the giga projects. So it's urgent to solve these problems from the early stage, from the design, from the scratches, and try to study these issues with the suppliers and fabricators, with the main contractors. So I think this is what we're talking about.
Great. Mr. Bassam, on the same topic about supply chain, how early do you think the materials decisions should be taken?
As soon as the design is finished.
Okay.
Okay.
Fair enough.
So yeah, actually we are witnessing a very big design leap and design innovation in the market now. in all disciplines. Okay, and if you remember, maybe 20 years back, the facade industry was part of the fit-out system. Okay, it was part of the fit-out BOQ, and one of the main reasons that make facade industry independent from the fit-out and from the finishing works is the fast innovation. The innovation and the development that happening in the facade market is much faster than other disciplines. I mean, MEP, civil works, or maybe some of the finishing items. So early the decision on materials gives a leeway for the contractor and the client to reserve a slot with the production line, or at least know when to reserve it. If I'm not going to reserve it when the design is done, at least I can plan when to reserve it, maybe in 1 year. Maybe it depends on the project schedule either. But from my side, I guess that it's very essential to make a decision on the material selection and especially on the mock-ups and samples and color charts. The material should be ready for execution once the project is deployed. This is my point of view as facade contractor, and this is one of the main reasons that the project is getting delayed. It's the mock-up and the samples are usually a milestone for project deployment. So in order to start production and installation, one of the main points is to have an approved mock-up. Approved mock-up means approved material. Approved material means approved material selection. And this is the chain that we have to follow.
So as soon as possible, it needs to be engaged. Okay, so I'm gonna move to something. I want to hear from you, Mr. Marwan, about if you can give us like a story or kind of a challenge for a real project that you faced because of delaying or late engaging of the facade contractor, and what is the biggest lesson learned from this example?
I want to comment on the state that we are in the Kingdom of Saudi Arabia these days. There's a boom, and when you are in a boom situation, you need to grasp all the material that you can. You need to grasp, to put a hold on all the resources that you want in your project early on, because you don't want to suffer the delays. A boom, when you're not in a boom state, the economy is not booming, you can sit back, a laid back state. You can always wait and until things get done, and then you will do it. The situation here is the economy is booming. Our problem, we had to book many resources early on before getting to the state of implementing them, even before the design and the shop drawings were finalized, even before the mock-up was finalized. We had to book many resources of the long lead items in order not to suffer the delays. This is real. This is a real life lesson that we've employed, and in our projects we transferred these lessons learned to other projects in the portfolio that we're working on. The contractors have a limited capacity. No matter how big they are, they have a certain capacity. You want to first come, first served. That's the reality of things. And you don't want to be the last to be served. I think this is the most important lesson.
Great. Mr. Bassam, I think you have something to add on that.
No, actually, I totally agree that this limited capacity, sometimes when you bid on a project and it took time to have a decision or something, and you get into your pipeline, another project, and you start working on it, and out of nowhere, this project should be deployed and should be executed with no time and fast track project, and you start collecting the people, either qualified and non-qualified, to put everyone on time, to put everyone online and start working. But this is construction, man. you can't boil an egg in 2 minutes. Yeah? It should take 15 minutes, and that's it.
It's a war zone. Really, it's a war zone.
Great. I'll back to Mr. Jafar, and I want to hear from you about some case studies or outstanding project that you think, oh, we here engaged the facade contractor really early and it was super efficient.
Yeah, see, actually, to be honest, a case study exactly that having my experience till this moment, it's not available. But in all cases, the early engagement, as we said, across the three main limitation, it will be a perfect thing for the project and will minimize many things, okay? What the experience that we face it till now actual is the late engagement and the effects and the delays that we face it due to these points, okay? When we are speaking about early engagement, not only awarding the contract in early time, no, we are speaking about the facade specialists need to be involved in the design stage itself, in decision making, in material selection, in sources and vendor list arrangement. Okay? So this one till now, I didn't see it in one single project. When we are speaking about the mega projects or the projects for the boom or the largest project scale here. For the smaller projects, it's not affecting more because it's something locally always, okay? Since the most important issue actually is the supply chain stability and the procurement stability and the long lead term items. This is affecting. And in many previous projects, without naming, okay, the BMC, the consultant, and the client, they approve changing some of the material, okay, or they reduce the specification or the required quality due to the link lead time. So the early engagement as a benefit will save not just the cost certainty or the time delivery for the project, the quality, which is which is the first important actual category in every project. Okay, always we have quality, safety first. So early engagement will allow you to confirm the quality with the best requirement as per the original design. So since no any changes will happen for the vendor or for the sources or for the specification due to the long lead item.
Great. Mr. Sommer, just a question about, now we know kind of the overview or everything, I would say, about the importance of engaging the facade contractor in early stages. But I think, and correct me if I'm wrong, some clients don't like that. For some reason. Can you just give us a glimpse about that?
Good question. So regarding, we face these problems always as a designers with the clients. So always we try to, if you see, as per our vision here, the Saudi Arabia vision, we need to go with traditional materials, and we try to make innovative for this materials, but it's very limited, you know. So we try to go with alternative material of the traditional one. So we can, talking with the client first to try to approve the concept of the design and the concept of the material chosen. This after integration with the contractor and fabricators. So let's say always the client put some problems for us, maybe always reject, or maybe the cost is a very big challenge for us with him. Okay, so the client always try to, or they want to make a clarification for the design, and what about the material specifications which we choose. From this way, we can try to go with value engineering regarding as a project, total project. So we go with the facade and keep the facade as an element from the square meter of the building. So from this way, they can accept as a cost. But regarding the innovation and regarding the alternative material, we try to, or we have to go with many factors like the availability, and try to let client accept that, and also the cost. It's a very important thing. Also the visibility of the project.
Great. I will move to such an interesting point, and this question will go to Mr. Walid and Jafar, because I know, Mr. Jafar, you're obsessed with BIM. So we're going to talk about not just BIM, the technology in general, and how it's super powerful when we involve this kind of workflows into the process in general. So I want to hear from you first, and we can move to you, Mr. Jafar.
Okay. Actually, BIM is still newborn in the Middle East. Not yet mature enough, let's say, frankly speaking. The implementation of BIM, it will help a lot for all the industry players. Since the BIM, it is a system of managing or let us say it in a simple way. Actually, we are building the building virtually before we construct it on reality. So whatever the issues that we could face it during the construction, we will face it virtually and sort it out virtually. Then we will go to execute on site. So having a BIM to be implemented in all projects, it will sort about most of the technical issues that could we face during the construction. It will save 30% of the project lifetime. That will help us, and will save money as well, because most of the solution will happen on the model, not on reality. We will not go with deconstruct or deassemble any part of the building, then to sort the issues. So we believe the BIM is a very important tool, will help all the players to mitigate the risk, to maintain the budget, and to maintain the project time.
And do you think it's kind of, because some people think it's underused?
Yes, it is. Actually, most of the people, they are using Revit as BIM. When they using Revit instead of AutoCAD, they said that we are implementing BIM. However, it is not the real. BIM, it is a management system. Should have the proper team, first of all, the proper awareness about the importance of BIM, because I will tell you a story happened in our project. From the design, we have insist that the BIM will be implemented from the design stage, and then we will control the RFI, which will go to the contractor to follow our requirements. At the end, I will get a model asset that will allow me as a developer to use it in facility management. Okay, so I have an objective afterward to have a facility management using the BIM. When the construction started, I start hearing the blames coming from the contractors and coming from my colleagues in the BMO. The BIM is, we don't have the calibers, we don't have teams to implement the BIM properly. Let us go to get the drawings by CAD, then we will implement this drawing to the BIM model. We refuse it. Because in this case, if you go with CAD in 2D and you have a shop drawing with CAD, then there is no benefit of having BIM. Just we are pretending that we are using BIM. So we rejected this request and we insist to implement the BIM. Nowadays, all the contractors, the subcontractors are working on the same environment without, there is some clashes, but tiny clashes. We can sort it out. All the players are connected on the same environment so they can take the decision on time. Because of that, the project is running on schedule.
That's super helpful. Now, Mr. Jaffer, tell me about your obsession with them.
Yeah. Mr. Walid, he spoke about the BIM overall generally, but I need to be specific to discuss the point on the facade. Today, when we are discussing the facade execution, the challenge is no longer producing drawing, fabrication material, or the complexity of the system. It's about the predictability, coordination, risk control, and management. It's how effectively we engage the facade in earlier coordination with all other disciplines in the project. As known, the facade work or the facade package carry out one of the highest interface density on a project, intersecting with structural, architectural, MEP, fit out, and with all other disciplines. So any gap in the coordination in early stage, it will convert to delays, cost, disputes, and the clashes during the execution. Therefore, exactly the BIM become one of the most essential and important tools. For me, actually, it's not 3D modeling only, it's a risk elimination tool. Through the 3D model coordination and federated modeling, we detect the clashes even before we start the production, validate the tolerances, align the design with constructability, instead of discovering the issues and conflicts on the site. After this, even in the execution time, BIM based sequences and 4D planning for smooth installation front, for access methodology, for lifting plan, logistic, and even safety plan, which make the facade predictable rather than reactive. To apply this one, we are using common environment data like the Autodesk Construction Cloud that elevate further than to keep all the modeling, shop drawing, and information updated and synchronized in one live platform. Everyone, client, BMC, consultant, contractor, or subcontractor work from one source of truth. And this is eliminate the confusion at the site, reworks, and other disputes. But to make this success actual, we need the facade contractor, if we are speaking about facade, especially, to be engaged earlier, or the BIM will remain beautiful 3D modeling without adding value on the project coordination or on the risk control and management. In simple word, ultimately the success of facade is not only aluminium, glass, and the brackets. It's how to coordinate it. It's how to deliver it. It's how to arrange the material early, without the clashes, without rework and repetitive. And here, where I believe that the BIM can help us. Right now, I will comment on one word. We are facing a problem that most of the project, okay, they are requiring the BIM, as he said, for the facility management. Guys, it's for the facility management, this means that for operation as built and after the construction. But actually, it's supposed to be from the design stage till the final handover. It will be the whole story for the project, that it will be handed over in the operation and maintenance to the client to submit it to the facility management. Thank you.
Thank you so much. And thank you for all of you. It was really amazing. And I'm honored to moderate this with such experts and amazing experts in this topic. So thank you so much. And thank you for all of you for listening. I hope you enjoyed this. So now I think we need to wrap up. So let's just take a group photo and we will wrap up the event. Yeah, let's go a little bit closer. So thanks to all of you. Thanks for Zak for arranging this amazing event, and thanks for you to book this time, the whole day for this event. I hope all of you enjoyed and share and exchange knowledge with all of your colleagues, I would say now, or your friends or your whatever. So thank you so much. I hope you enjoyed that.